Hello, everyone. Hello. Thank you. Welcome to GUADEC. Woo! I appreciate that. Hi, I'm Richard Littauer. Almost none of you know me. Some of you know me, which is cool. You know me. Love you. And I'm just really excited to be here. I'm the interim executive director. To save the faff of someone saying he's the interim executive director, let's have him come on. I'm just here. So, hello. Hi. I have some opening remarks. Yeah, that's fine. Yeah. And then we'll get to the good stuff. Thank you, Cassidy. All right, so first off, number one on my list, thank you all for joining us. Okay, we did that. Thank you for everyone who's joining us online. It is really great to have you here. I believe this is streaming. I'm not sure. There's a guy on a desk. It is streaming. Online people, you're amazing. Thank you for coming. And I'm just really excited to everyone who also came. It's great to have you here in Denver. It's great to have you here in the US. Haven't had one of these in a while, I think ever. So very excited to have our first US GUADEC. And this is just great. That would not be possible at all without our sponsors, who are amazing. The main sponsor is Endless. Due to, I think maybe my mess up. I don't know whose mess up, but let's just blame me. They're not there, but they are the biggest logo. So just Endless, thank you so much. You're awesome. And I also want to thank our gold sponsor, Ubuntu, who are also awesome. So thank you. We also have other amazing sponsors who are the best. And thank you all for being here. And some of them are around this room, I know, so go up and thank the individuals who made that happen. This will be our venue for the next 3 days. You don't have to go other places. If you're somewhere else, you messed up. Come back here. We have an open sign up for lightning talks. So if you're not giving a talk, or if you are and you want to give another one, we can do that. They're on a first come, first serve basis, just like lightning. So if you're interested in presenting, sign up at the registration desk over there. Coffee will be over there for those of you who are just waiting for me to say that. All track one talks take place here. This is room 250. It's Turnhalle. If you're already here, you know what it is, so just come here. I don't know how to pronounce Turnhall, so I just went with it. Track 2 will be in room 444, Lorraine. Lorraine Good, located on the 4th floor, so you're going to have to go up somehow. There are elevators outside. There are also stairs. And it should be over there. There's signage that will get you there. And there are signs that will guide you to the tower elevator if you want to use that one. If you need directions, because this is confusing, anyone with a red shirt that says GUADEC, not you, because you have a red shirt, but it's different, that's okay. Everyone else can help you. Or anyone with a yellow hat may be able to help you, almost certainly, because they're also here in a professional capacity. And we've scheduled 5 minutes between talks, so you can go to your rooms. So it should be okay. If the people go over at some point, just politely, everyone leave. Or not, just be polite. There will be a break around 10:30. Was it 10:30 for coffee? Do you know? Yes, 10:30, so cool. Wait till then. Social events. Cool. I really don't like just going through a document and listing stuff, but thank you for being patient. Saturday, 20th of July, we have the Women's Happy Hour. For more information, come to the registration desk. That would be great. Saturday, Tivoli Brewery also has a happy hour with beer specials, giveaways, and other things. So if you like beer, that's great. This is also an old brewery, which is really cool. So it was converted, so they know what they're doing. So that might be fun. There are also non-alcoholic drinks. On Sunday, we have the official GNOME dinner at the Tivoli Brewing Company, 900 Aurora Parkway, which Google will help you find, or other places like OpenStreetMaps. On Monday, there's a baseball game, and that'll be really cool if you like baseball. If you don't like baseball, I've been told that you actually really just go for food. So either way, it will be fun, and you should totally go to that, and that will be cool. And on the 24th, we have a city tour, which also starts at 10:30, or as Americans say, 10:30. We still have a few more seats left, so if you're interested in joining, do so. That'll be really fun. And of course, all this information is online. But that's what's happening. It's awesome. Okay, we very seriously are very serious about our code of conduct. We have a code of conduct. It is online. It is in no way controversial that we care about our code of conduct. So if you have any issues here, if you feel unsafe, if you feel that someone has offended you, if you're not sure, contact someone with a yellow hat. I will not be wearing this hat. I don't know who database are. If someone else knows and they're all just grimacing, I'm sorry. It's just really hot in Denver. You can contact me. You can contact anyone with a yellow hat, and we will help. You can also email online. There is an email for the code of conduct. And that also works for after the fact. If you say something happened this morning, that's fine. So I just want to let you all know. You can also ask one of the people in the red shirts. Again, they're also here for that. Code of conduct is not always enough. You can always call 911 if needed. I learned recently that actually 911 goes to Denver and it's really confusing and it takes a longer time. So use one of the university phones which are here to call 911 if you can. It'll be faster. Just a random side note. Kind of nice. So that's cool. Also involved with the code of conduct. The code of conduct is all about making sure you respect other people. And we have these lanyards, which is also about respect. Some people like being photographed or don't care, and they're wearing blue. Some people want to be asked, and they are wearing yellow. See, excellent job. Yellow, likes to be asked. And people with red do not want to be photographed. Don't ask them, just don't photograph them. If you took a photograph by accident, delete it. Maybe even let them know. That's fine. I think that's the end of the main stuff. Because I am, as you can tell, very informal and very non-professional, I'm just going to swiftly look this way and be like, did I forget anything? No. Okay, cool. I've gotten the sign off. So that's it. That was all really long. But the main point is that we're here and we get to talk to each other and we get to hang out at GUADEC and talk about GNOME and talk about the awesome people who make all of this possible. So thank you so much for coming. I hope you really enjoy it. I hope you make new friendships. I hope you figure out new things that you can do with the code together. And I hope that today and tomorrow and the day after and the rest of the year are awesome. So thank you so much. Welcome to GUADEC. Woo! I have no idea who's coming up next. It will be a fun surprise.
Evan, handily identified by this name tag. You can find me on GitLab and on Matrix. Okay. Don't turn that on that close. Do that. Run away. We tried. So you can find me on GitLab and Matrix under EWLSH, and then leading the second half of this talk will be the wonderful Philip Comento. You can find him on most platforms as P Tomato. We lovingly call him the JavaScript guru. Let's see. So what are we going to talk about today? So we're going to have a lot of different stuff to talk about, covering everything from using TypeScript to write GNOME apps, some exciting community-led documentation updates, what's new and what's next for JavaScript and GJS in 46 and 47, and a bunch of thank yous to everyone who's contributed to JavaScript in the past year and made it awesome. So just some general guidelines for the presentation. It's full of links, so if you want to click those links, don't come up here. Go to ptomato.name/talks/GUADEC 2024. I believe that's the year. And if you see little things like 46 circle, 47 circle, that's denoting what GNOME release the thing is available in, and the hat is just a big kudos to whoever did it. So let's start off with some exciting community updates. So you might be wondering, what is the state of TypeScript for GNOME? And if you're not wondering that, welcome. So earlier this year, we actually released the first beta of unified TypeScript definitions for GNOME. What this means, in essence, is that historically there's been a bunch of different community projects that have tried to bind TypeScript to G-object introspection and thus have beautiful, strongly typed JavaScript available. But they've all had their caveats, they've all had their issues. A lot of the projects peter out over time. And so the two largest projects, gi.ts and ts for gur, combined under the ts for gur namespace and combined all the cool stuff that each of them did into one beta binding. And Pascal is my wonderful contributor on that project, and he's been working tirelessly to fill in a bunch of feature gaps, which we'll talk about in a bit. And I've been doing some fun stuff like bug hunting. For instance, right now, the beta bindings don't support permissification. If you don't know what permissification is, we'll talk about it later. I want to give a big kudos to STF funding, though, because STF funding did push a lot of this over the finish line and introduce a great new language for GNOME. So if you're wondering how you can use TypeScript today, there's a bunch of different ways. The one I'll shout out immediately is Chris Davis, who's been working on an amazing TypeScript template for GJS. It has everything, batteries included. You can just get going, work on it, and have a great old time. And if you haven't used TypeScript before, I probably should have given an introduction to it, but I will now. TypeScript is a great language that sits on top of JavaScript and adds, as the name suggests, types. So you can do really cool things on top of JavaScript's functional programming styles and object-oriented programming styles to strongly type check JavaScript code and add a bunch of cool documentation and other things along those lines. And if you're like, oh, I don't want to switch my whole code base to a different language, well, guess what? You can even use the TypeScript compiler on JavaScript to lint for things like, incorrect variable assignments, incorrect variable names, mysterious bugs in the shell, lots of fun stuff. I would say most apps for GNOME should in general start with the TypeScript template, simply because it's set up to work with GNOME easily. If you're more experimental, like I am, let's talk about the beta bindings. So if you're currently developing a shell extension, or you're very adventurous, the beta bindings are currently published as NPM packages. If you don't know NPM, it's the node package something. And it's essentially a big ecosystem of JavaScript code and packages that are published there. It's also going to be published on some other repositories so you can access them without going through corporate NPM land. But in general, distro packaging with NPM packages is not very simple, and distro packagers don't love having to deal with them. So if you're building an app and you want to send it to the distros in the masses, maybe avoid the NPM packages for now and stick to the actual template, which includes all the TypeScript stuff in the repository itself. But if you're doing shell extensions or cool things like that, you can get started right now with some amazing TypeScript bindings. The link, if you go to the website, is clickable. And there's even a guide on gjs.guide, which we'll talk about later, that tells you how to write TypeScript for shell extensions. Right now, Pascal is working on a great new update that will actually allow the beta bindings to easily integrate with the GNOME template. We're expecting it in like a week or two. So the beta bindings will probably transition to stable in this cycle, and we'll have some amazing new TypeScript bindings. Maybe the shell will even see them soon. Hi, Florian. Some other really exciting community initiatives that have been happening in the last half are GJS.guide and the template, as I mentioned previously. The cool thing to note on this slide, though, is that they have a new home. So we now have a JavaScript organization on GitLab under World. So you can find GJS.guide, which is documentation for the language and the use of it, and also the TypeScript template there. And we expect more and more fun projects that are making JavaScript amazing to migrate there. So speaking of GJS.guide, let's talk about it a little. If you don't know what GJS.guide is, it's a documentation website for everything JavaScript and GNOME. It's actually the URL. So if you type in GJS.guide, you will go to the website. So this year we did update it to a newer stack. So it has better search, better navigation. It works better on mobile. It has a dark theme, which had a few glitches, but we've mostly ironed them out, and lots of other great, technical improvements to make it easier to work with. I'd also want to give a huge shout out to all the amazing people who've been writing documentation on the site to make JavaScript easier to use and easier to learn about in GNOME. We have a great documentation that was written by Andy and Javad on extensions, the shell, and GNOME 46. Andy's been working hard on dbus documentation, and also Nitin, who is, I believe, a relatively new contributor, worked hard on ST widgets. So if you've ever tried to use shell widgets and are a little confused, either an extension or the shell itself, there's now a great guide giving examples and how to use them on GJS.guide. Also, a massive shout out to a bunch of other folks who've done small fixes, small examples, tweaks to the documentation, fixing code bugs, and a bunch of other work on the site this year. I could try to read off all those names, but for time and my sanity, I probably will not. I think the coolest one, though, is ByteZ. We don't know their official name. They go by that moniker. And then I think the last community project that we want to shout out right now is Workbench, which is a really great project that has made JavaScript and many other languages in GNOME easy to just jump right into. So you can essentially, if you look behind me, you can write code, you can write styling, you can write UI templating and Blueprint, for example, all in one app, and then you can preview it, run it, and just get going right out of the gates. I want to say that right now, this year, they've added a lot of demos and examples that align with the HIG, introduce people to GNOME concepts, and in general make it easier for new contributors to say, hey, how do I build a GNOME app without, firing up Builder and being overwhelmed with all of these options and languages? This improvements that are specific to us, though, are TypeScript support. So the bindings have made their way into Workbench. So if you're curious about just testing out TypeScript and seeing how it works in GNOME, you can write it right in Workbench. I think the Flatpak has been updated with that version. If it hasn't, look for it online. And you can test out TypeScript without installing anything, monkeying with beta bindings, or anything crazy. A major kudos to Angelo, who worked on that. And I think with that, we're going to transition into what's new in GJS for GNOME 46 and 47. So one really exciting improvement is some console output fixes. So I'm going to butcher some of these names, but I'm going to do my best. So Sriyansh worked on improvements in logging repository namespaces. So if you log like the glib import, for example, it doesn't all explode or show some weird code that you have no idea what it does. It says, hey, you've imported glib. Gary also worked on improvements in logging some of the data structures in JavaScript, which if you haven't used them before, they're things like unsigned integer 8-bit arrays, and also logging things like param specs. So if you're defining GObjects and you want to say, oh, hey, did I define my param spec correctly? You can actually now log those using console.log. And then in general, there are improvements to pretty printing and making console.log, the REPL, and the debugger all work more happily and harmoniously so that we have, a working system that people can easily debug. I want to say, I believe it was NASA that added a lot of the pretty printing work this past cycle. Her work has been amazing in adding pretty printing and also fixing a bunch of issues that we had across. Philip, do you want to add anything there?
Yeah, actually a couple of years ago already. We've had it for that long. Yeah. Amazing,
Philip,
isn't it?
I mean, I only added that because you added the speaker note for NASA, Philip, so I was like, oh, was I supposed to shout them out? I guess we have last year's speaker notes in here. That said, 46 and 47 does actually feature some great performance improvements. So Marco, hey Marco, did some amazing performance improvements for setting and getting GObject properties. So now those work faster and better. And there's more improvements to come on that. I believe, Marco, you have several MRs in flight that Philip is diligently working through. So stay tuned for 47 and 48, where GObject properties will get even faster. And then this one is something I worked on and I'm particularly excited to mention. So thanks again to STF Funding for sponsoring this. But we actually have GTK.accessible list in GJS now, which means that you can actually fully define GTK4 accessibility relationships in your apps. Woo! So if you have, for example, a labeled, I think that deserves a clap, yay! Accessibility. So if you have something like labeled by where you have a list of things that are actually labeling it, or if you have a relationship that's like, hey, I have these multiple things related to this or describing this, you can actually do that correctly now. So you just have to call like new gtk.accessible list, pass in the widgets that are part of that list, and then update the relationship in GTK4. I think we're going to work on making this a little bit more ergonomic over time, but you know, it finally works, which is exciting. And this is available in 46, I believe. And then I think the last slide that I'm going to be presenting is an update on async support. So if you remember permissification from earlier, what that is essentially is turning those old async methods that are like, you know, I don't know, read file async, and then you have read file finish. It's taking those and turning them into JavaScript promises, which means you can use the await syntax, which a lot of languages have now, and say like await gio.readFile or something along those lines, without having to do extra work and callbacks and complexity. So right now we have a utility called gio._permissify that if you pass in a specific GIO method, it makes that method capable of using this pattern, but having to explicitly call gio.permissify on everything is a bit confusing and can lead to bugs. For example, you know, in the shell, if an extension developer or a shell developer adds a gio.permissify, suddenly you have a function that sometimes is permissified and maybe sometimes not. So we're working on native support for this. So as of 46, GObject introspection actually now has async annotations. So those GIR or GIR files actually have all the async annotations now in them. So, you know, if your language is ingesting GIR files, for example, the TypeScript bindings, Vala, you can use those to actually figure out how to exactly map functions into their async versions. But now we're adding the runtime support. And so runtime support will mean JavaScript can directly integrate with this and make all async methods work with await syntax and promises in general. So we're expecting this for 47. If you don't know, there's been a pretty big migration of a lot of the GObject introspection code into the glib repository. And so as part of that, a lot of the work around this had to get reshuffled and rebased and fixed and changed to integrate with the glib repository. But I think we've now got the Fedora pipeline passing, and we just have to fix some bugs in that Windows pipeline. And then async support will be merged, hopefully for 47. And again, if I didn't mention it, thanks to STF for funding a bunch of this stuff and making progress. I think at this point, I'm going to transition it over to the amazing Philip, who's going to talk about JavaScript engine upgrades and a host of other exciting topics.
Thanks, amazing Evan, for that introduction. It's, really nice to see you all again and be in this this lovely venue. Also about async support, I want to mention I'm really excited for this because this has been a long time coming. It was also originally the work of two of our outreachy interns from several years ago, and it's
my GSOC year, 2018.
Yeah. It's great to see that we are we might finally get it over the line this year. So I'm going to switch to the part of the talk where I talk about general improvements to the JavaScript language. You'll see these improvements coming to browsers as well, and we're bringing them to GNOME. So this, I almost always have a section on this, like what we'll get when we upgrade the version of the underlying JavaScript engine to one from a newer Firefox. So this year we're planning to upgrade to the JavaScript engine from Firefox 128. That's their extended support long-term release, and it brings a bunch of new stuff. It used to be like sort of these earth-shaking new syntax things like classes and promises and all that. That's settled down a bit, but still there's a bunch of exciting things. We have a new internationalization facility, Segmenter. Intel.Segmenter is a facility that lets you split strings into graphemes, words, or sentences according to the locale rules. So like if you take the Mile High City with a hyphen between mile and high, and you naively split the string on spaces, you're not going to get the correct number of words in it. The string has got 4 words. And different languages have different rules. Like some languages don't use spaces, so if you split on spaces, you're not going to get different words. So if you are building a locale-aware application, this is a useful thing to have. We're going to get group by. This is such a useful thing that many utility libraries in the wider JavaScript world already made their own version of it. Like Lodash had Lodash.groupby. This allows you to partition an array or other iterable into groups depending on the outcome of a mapping function. So we have 2 group bys. We actually have one that'll do it into an object and one that'll do it into a map object, just depending on what you want for your application. We're getting promise.with resolvers. This is kind of a niche one, but it's useful for integrating promises with signal-based APIs. So I have like a code example here of like if you have a WebKit download object and you want to convert that into a promise that you can await when the download is finished. Normally you'd have to connect to the GObject signals, and this code would be a lot more complicated spaghetti if we didn't have promise.with resolvers, because you'd have to like capture the objects in the promise executor callback and blah blah blah. You don't have to do that anymore. This is simpler. We're getting array buffer transfer. This is useful if you're using data buffers and you want to pass them to an async function, and you're afraid that some other code might change them while you're waiting for your async function to return. So the transfer method does a zero copy ownership takeover. It invalidates all of the old buffers and makes sure that you are the only owner of the new buffer. So here's a little code example where something like this might go wrong. You have async validation of an array buffer, and then when the validation finishes, you want to write it to a file, and then you have this adversarial set timeout down here at the bottom that's going to change your buffer after 5 milliseconds. That's not good. So in your validate and write function, you want to transfer the array buffer, make sure that the set timeout, it doesn't have access to the buffer anymore and can't change it. So there are a couple of things that you'll have to update your code for in this cycle. Most people won't have to update their code, but these are kind of, if you're doing this, then you might need to change. So the first one is new namespaces for platform-specific APIs. GObject introspection moved into glib, and I think Philip Withnell is going to give a talk on that later in the conference. We got these separate namespaces, glib Unix, GIO Unix, etc. The old namespaces are still going to work for the time being, but you'll get a deprecation message if you're using a platform-specific API, but loading it from the not platform-specific namespace. So things like Unix connection or
Unix pipes.
yeah, Unix pipes. But yeah, that should be fairly straightforward. You'll get a warning, and all you have to do is change the namespace that you import it from. These code snippets on the second line, maybe I should have really devoted a whole slide to this, because it's like this huge pitfall that's existed in GJS for decades. And people write bug reports about it all the time, and until now we've always said, oh no, I'm sorry, but you are actually doing it wrong. But we figured out a way to make to make it less likely for people to make this mistake. So all of the GObjects that we bind in JavaScript, they have constructors that take a property object, or it's sometimes in the JavaScript world called property bag. Like that's the first one here, new GIO file icon, and you pass an argument my file. My file is supposed to be an object with properties, but if you get it confused with the static method new, which also automatically exists because it exists in C, and so we have a binding for it, which takes a GIO file object, and you accidentally pass that to the constructor, you're going to get, it's going to look for properties on that object that aren't there. And that will often lead to incorrectly initialized objects which then later on go on to crash. So we've changed the constructor so that it only accepts a plain object, not a GObject. And you'll get an exception if you try to pass a GObject there. I hope no one was relying on the old behavior. It's possible that maybe you were. If you were, try to migrate your code, but if that's not straightforward, then let us know and we'll revert that change in favor of a longer deprecation period. All right, so the last line on here, many crashes were caused in the past by trying to use C-only APIs from JavaScript, like reference counting and pointer stashing. JavaScript doesn't have pointers, and you don't need to reference count. So for some reason, we'd always left these methods available for you to call and crash your application. I just had to rely on telling people don't do that. These won't work now. We just block them. I'm not sure why we didn't do that before, but these were particularly bad, the reference counting ones, because if you used them, sometimes they would crash, or sometimes they would appear to work, or sometimes they would crash later. So if your code uses them and it appears to work, well, now it definitely won't work, so just delete it. All right, I'm going to also tell about a couple of things that are coming down the line in future JavaScript updates. This is the exciting part, because I also kind of get to talk about what I do in my day job here. I'm a member of the TC39 committee that standardizes the JavaScript language. I do that on behalf of Igalia, and so I've been working on some of these proposals, trying to get them into JavaScript for future browser updates, and I'm excited to present some of these. Here are some things that are already implemented in nightly Firefox, so we'll be getting these next year when we do the next update. We get a bunch of exciting new methods for set objects, like union, intersection, symmetric difference, a bunch of cool stuff. We're going to get resizable array buffers. The transfer thing was already sort of a vanguard of that. It's meant to work with these, but yeah. You'll get buffers that you can grow and shrink. So these we already know are going to be in next year's SpiderMonkey update. There may be other things too, but we'll have to see how, whether Mozilla implements them this year or what they decide to do. Another interesting abbreviation from the JavaScript standardization world is WinterCG. It stands for like Web Interoperability Runtime Community Group. So this is a bunch of non-browser JavaScript runtimes who got together and said, "Hey, let's decide on what we want to say is like a common minimum API for JavaScript environments that's not necessarily, or things that are not officially part of the language, but that everybody kind of relies on. Like set timeout and set interval, those like people, and console.log, people expect those to be present. We have them in GJS as well, but they are not officially part of the JavaScript language. They are additional APIs. So this group has been plugging away on this common minimum API proposal that includes things like the ones I mentioned, and also other things like basically B to A, A to B, fetch, things like that. So I'm curious if anybody from our GNOME JavaScript community would be interested in joining this group on GNOME's behalf. Come find me after the talk, and we can talk about that. But this would be really interesting for us, I think, because we are a non-browser JavaScript runtime, and we have actually a pretty unique niche in that we power a desktop rather than a server. There are other exciting proposals coming 2025 or 2026. There's Temporal, which this is the thing that I do most of for my job. I gave a talk on it. You can click the link here if you want to know more about it. But I've even seen bugs reported in GNOME Shell that would be solved by using Temporal. So I'm excited to see that finally coming to SpiderMonkey, hopefully, and I'm excited to use it in the JS code of the shell. Decorators, we've been eagerly awaiting these for the better part of a decade. I first wrote a blog post on designing a decorator API for GObject classes in July 2017, 7 years ago. And they might be coming next year or the year after. Iterator methods. So if you've written code in Rust or Python, you've probably gotten used to iterators. Like, we do have iterators in JavaScript already, but they don't have as many facilities as they have in other languages, and that's going to be remedied very soon. And then using statements, that's a bit of exciting new syntax in JavaScript. They're kind of like context managers in Python with blocks. They'll be quite useful for explicitly dropping resources that need to be cleaned up, like closing streams and disconnecting signals and stuff like that. That's a bit of a hassle in GJS right now because it's not always clear, like, oh, do you leave it for the garbage collector? Do you clean it up manually? If you rely on it implicitly being cleaned up by the garbage collector, that often runs into problems with callbacks being run during garbage collection. And so using should make this all really simple and streamlined, I hope. There's something coming a bit farther in the future, but that I'd like to highlight because I think it's really exciting, and it could affect the way that we do internationalization in JavaScript apps in GNOME. Like, getText is kind of central to our translation workflow, but xgetText, the tool that extracts the strings from source code, it has never really integrated well with JavaScript source code. It's just flat out broken for backtick strings. We've tried to fix that, but haven't really been able to. Intel.message format is something that's coming down the standards pipeline in maybe a few years. That is kind of a new, more expressive API for doing this, but also could work as a superset of getText. So we could still consume getText files, but if we need to translate them in JavaScript, we could have a bit more of a JavaScripty API for doing that, and JavaScripty tools. So I think we'd be interested to get a proof of concept of this working with the early stage message format proposal. And so on that note, the section I'm going to run through fairly quickly. I'd like to take the last couple of minutes of the presentation to really boost Intel, because I think we don't use it enough in GNOME. It's it's part of the JavaScript runtime. It does internationalization stuff. We do getText stuff. Intel doesn't do that yet, although it might with message format. But some things are actually awkward to do with gettext. Intel makes those easy. We have all these fantastic facilities in Intel, formatting all kinds of stuff in a way that's appropriate for the user's language. I have like an example actually from GNOME Shell that we ask translators to translate strings like these. How on earth would I know how to translate this into my locale? Well, I don't know. Why don't you just read the manual for strf time? Oh no! So the translator does that, and then you're integrating the work back into GNOME Shell, and you see this. What on earth is this? Now I have to read the manual for strf time. So, like, there's an easier way to do this. It might be longer, it might be a bit more code, but it's less burden on GNOME translators. You create a datetime format object. You say, I want a medium-sized date and a short time in 24-hour clock, and then it just does the right thing for your locale. And you don't need to burden your translators with this. So you might ask, like, well, okay, if the translators aren't giving this data, who is? There's a project called the Common Locale Data Repository that most of the major JavaScript engines get their data from. This work is sponsored by major browser vendors, and it's done by people who take surveys all over the world of people in speaking different languages and in different cultures. So this work is paid for and freely available, and we should take advantage of it. And even if you want to tweak it, you can still do that using format to parts. Like if you don't like that Intel uses a colon as a time separator and you want to change it to a ratio mark because that's typographically more correct, you can do that. All right. So we have somewhere in between 5 and 10 minutes left. So I'm going to throw it to questions. I'd like to thank everybody who contributed to GJS or the wider JavaScript community in GNOME, the TypeScript, the Workbench, the GJS guide, everything. And here's the license for this slide deck. You can reuse bits as is with attribution and not for commercial use. And I like cats.
I think Christian, way in the back.
This is, I guess, more of just a comment quick and a thank you for implementing the parts I needed for libps. For those that want to extend their other applications with GJS and provide like a scripting language, plugin interface, etc., all the new stuff works with libps. It's a very convenient way to manage plugins. It's extremely battle tested. If you think about Builder, it's got hundreds of plugins at this point. It's very easy to come in and write a concise type of plugin. You can use it with GJS now. So if you have another application, you can both consume libps from other languages than C, and you can also extend your APIs using GER, type libs, etc. With it. And then again, just wanted to say thank you to Philip for doing the hard work that I needed on the C++ bits to make that work.
Thanks.
This is also another comment, more than a question, but the presentation application that I always promised to finish before GUADEC, and I never finished for the past 4 years, it is using libps and GJS, and I can attest it is fantastic. So it's pretty cool. Yeah, that's it.
Do we have any more questions? Yeah.
Actual questions, although I'm not sure how useful they'll be. Is that your cat? What is his name? And does he know he's gorgeous?
Oh, it's not my cat, unfortunately. It's a The image is titled IR cat.
This is the GNOME cat. It's official.
Can we adopt him? Okay, so I'm kind of interested in, I don't really know what my question is, but when you're talking about using Intel as opposed to, the horrible strf time thing, I think one of the tensions there is Intel is only in JavaScript then, so there's this danger of us having like multiple ways of doing date time. And I don't know, what are your thoughts about that?
I have an answer.
Yeah, go ahead.
So I actually have run into this problem a bit in my professional life too, because I work for a mental health company, and we distribute applications in a variety of in languages like Python, some stuff getting into like Rust, etc. And we wanted to essentially stop paying a lot of translators in a lot of languages to translate like date, time, country names, when sometimes it wasn't even correct. Like we would get feedback that was like, oh, this isn't right for my specific region of this country or something. And so we switched to Intel pretty much entirely. What I will say is the CLDR database is completely open, and there's actually a surprising amount of bindings into most languages. So I believe Rust has a library, or actually might have directly integrated it into the language. I'm not totally up to date on that. Python definitely has a CLDR library and also has utilities that built out around that. C, I think, is a bit tricky in that a lot of this is like the core libraries were Java and C++, and then have extended out into JavaScript and other languages. And so C, I think there has been some work. Actually, I think someone may have been working on like a Rust library that exposed a C interface to actually use some of this Intel stuff in C. It's a very burgeoning field. What I'll say is like, it's not just browsers, like your mobile phones, pretty much every like bit of technology you use that is in some way touched often uses CLDR data somehow, somewhere. Like the entire Android localization stack uses bits of CLDR throughout all of it. So I would say like, I think we should be open to exploration, and there's a lot of interesting library work that's happening because this data is generally so much better than what one project can do. And you can reach languages and places that, GNOME has no translations for, but at least we can show them the time correctly, the date correctly, and kind of like the basic functionality of a computer correctly. Do you have anything to add, Philip?
Yeah. It's a good point that you might have like one piece of code that uses Intel and then another piece of code not in JavaScript that doesn't use it. And if you need those to be consistent, then yeah, I'd say don't use Intel for that, or try and use one of the bindings for ICU and CLDR in the other language.
To add on to that, what we did at work is we literally have a script that builds like static, files of like date and time translation formatting. So we have consistency across like JavaScript applications and elsewhere. That's not open source, unfortunately, but there is a lot of movement like across, I think, most languages to work on this. I got the 1 minute sign. So do we have a last question?
Thanks, that was really helpful.
Any more questions? Okay, yeah, I think we're good.
We love the Mozilla shirt.
Yeah, I think we're good, yeah.
Okay, well, thank you, everyone. Over to Melissa.
I think when we submitted the talk, we put Benjamin's name on the speakers list as well, but it's just me. It wasn't practical to do this in a hybrid form, so I tried to represent whatever Benjamin would have told you. Yeah, about myself, I've been working on GNOME for a very long time at this point. So if you're using GNOME, you probably run code that I've written here and there. It's all over the place, but my home base really is GTK. That's where I work most days, so I kind of want to talk about GTK and present highlights of things that have happened since last GUADEC in GTK. The title of the talk that we submitted was a deep dive about the new renderers. And the new renderers are going to be an important topic, but it's not the only topic. I'll just talk about everything that happened in GTK, and we'll see how it goes. But before diving into technicalities, I want to set the stage a little bit and explain a bit about the environment in which GTK operates and the large-scale organization of things. GTK is split into several major parts. One is GTK, which is the windowing system abstraction. That's where you find the code for the macOS backend and for the Windows backend, for example. Then there's our new rendering system called GSK, which maintains a scene graph for us and translates that into drawing commands. That's a bit newer. We introduced GSK in GTK 4. And then there's GTK itself, which is where the widgets live that applications use to present things on screen. And originally, when GTK started out, the GTK APIs were modeled on X11. That was the windowing system that was en vogue back then. And nowadays, with GTK 4, we try to follow the Wayland APIs to the extent that is practical. So instead of windows, we now have surfaces, and our surfaces don't have global positions anymore. That's just an effect of following what the Wayland APIs do. And for the rendering, drawing in GTK has been done by Cairo ever since Cairo was introduced in the early 2000s. And with GSK being our new rendering layer, we now have a scene graph that we can use to do rendering, and Cairo is kind of getting less important as the drawing API, and the GSK renderers can translate our scene graph, the render nodes, either into GL drawing commands or Vulkan drawing commands, and as a fallback, there's still Cairo if all else fails. For the widget part, the story is a bit different. GTK is a big code base. We have more than 700,000 lines of C code, and there's really only a small group of people who work regularly on it, apart from myself. That's Emanuele, Benjamin, Carlos, Jonas, Christian, who's somewhere here, and a few people who work on other backends like Junwei and Luca on Windows, and Arjun and John for macOS. So that's really a small group of people for a big code base. So we're constantly looking for ways to shrink the scope and have less things to worry about. And one thing we found that kind of aligns well with other goals we have is to try to push the front-end API, the widgets, towards other libraries so that we don't have to worry so much about changing those, and they can develop at their own speed. And the libraries to mention here are examples like libadwaita or Granite for elementary. And maybe eventually this XApps effort might grow their own as well. Collectively, we call these the platform libraries because that's where the platform user experience is defined, basically. And for us in GTK, that means that we don't have to worry so much about following the latest design trends and keeping up with widget tree that's changing. We can focus more on plumbing and infrastructure, which is a good thing. So if you want to hear about exciting new widgets, you have to go to the Advaita talk, libadwaita talk, if there's one. And I will instead talk about more lower level things, which are still exciting, hopefully. With that, I'll switch to talking about some of the things that have happened since last GUADEC. As I mentioned, GSK has kind of made the importance of Cairo has lessened the importance of Cairo as our drawing API. We now have SceneGraph that takes over from that. And we can even imagine a future where Cairo does not figure it out in our APIs. That is certainly GTK 5 discussions and plans, but to get there, we kind of need to start somewhere. And one thing that Cairo does, it supports path rendering. Paths are basically free-form Bezier curves, and Cairo supports stroking them and filling them. And to get us step-by-step closer to a Cairo-free future, we introduced GSK paths, which basically takes over path modeling, and we also have render node APIs and snapshot APIs that go along with that. So we can do things with paths now without having to rely on Cairo directly. Of course, the implementation underneath is still using Cairo for some things, but at least the API is free of Cairo now. And we would encourage everybody to try it out and tell us what works and what doesn't work, so we can fill the gaps and make a path API that actually lets you do cool things. We haven't seen much adoption yet. I mean, the path API rolled out in GTK 4.14 at the beginning of this year. We do have a few demos in GTK demo. This is a screenshot of one of them. I tried, but I could not figure out how to make videos embed into this presentation, so I just have a still image. If you run this demo for yourself in GTK 4 demo, you'll see that the arrows are like little marching ants. They march around the outlines of the continents, and they change colors as they do. So that's a neat little demo, and maybe give some idea for what you can do with paths. Right, moving on from paths to the next topic. I already talked about that the GSK gives us a scene graph, and the renderers in GSK walk this, it's actually a tree, so they walk this tree and translate the render nodes into drawing commands. And that is pretty powerful. You can do a lot of things with that. But it also introduces some overhead. And there's some situations where you really don't need compositing and translations and effects. One example would be showing video content or image content. Most of the time, you really just want to see the video, and you don't want to have effects on top or UI elements on top. You want to focus on the movie you're watching. And so for that, it would be nice if we could just avoid the overhead of the rendering step and the compositing. And to make matters worse, for video at least, it is often the case that the content actually is already on the GPU side because it was decoded by the video decoding unit of the GPU. And then if we use it in our scene graph, we might have to download the content back to the CPU side to use it for compositing. So that's not great. And we wanted to do better than that. The kernel has APIs that let you handle memory without having to download it. There's something called DMA buff, which is basically the kernel API for identifying a piece of kernel or device memory with a file descriptor and attaching some metadata about the format of the data. And then you can hand it around from one kernel component to the other, possibly through user space, without having to download the data. And last fall, we added support for DMA buff to the texture abstraction that GTK has. And what we also did is we added support for subsurfaces to our Wayland backend. That might get some people excited, I guess, if I mention subsurfaces, but I wanted to say that this is not actually exposed in any APIs. We just use this internally. So if you want to use subsurfaces in your application, you still have to do it yourself. But yeah, I also wanted to say that this is obviously Linux specific. DMA buffs are something that only exists in the Linux kernel, and subsurfaces are Wayland specific. So currently, this is very specific to running Wayland on Linux. It would probably be possible to use similar concepts on other backends, other platforms, but nobody has done the work so far. But with these two pieces together, we have the infrastructure and had the infrastructure in place to actually implement graphics offloading. We added a new widget called GTK Graphics Offload, which creates a subsurface. And then our renderer, when it sees one of those subsurfaces, it attaches a DMA buff that it finds somewhere in the node tree. And thereby, we bypass the compositing step that the GSK renderer otherwise does. And if you get really lucky and the right circumstances are there, for example, the window is full screen, we might even be able to also bypass the compositing on the compositor side. And the compositor might be able to directly use the DMA buff and pass it on to the kernel APIs, which then gives us a zero copy path from decoding the video all the way through sending it from the client to the compositor and eventually getting it displayed on the monitor. It is pretty difficult to take a good screenshot of this because when we added these things to GTK, we worked very hard on making it transparent. So there's lots of things that can go wrong between the kernel and various drivers and GStreamer with DMA buffs. These formats need to be negotiated between the involved parties, and sometimes that fails, or the two drivers don't understand each other properly, and then this offloading fails. And we worked very hard to make GTK, in that case, fall back and just download the content after all and use this in our compositing as normal so that things just look the same, even if they are less efficient. And for that reason, giving you a good screenshot of how this looks is pretty much impossible. So what I have instead is a little illustration here that kind of shows you how you need to think about offloading. You see the main surface in the back, where GTK renders the window decorations and the buttons in the header bar. And then you have a subsurface that is layered, is stacked above it, where we have attached one frame of the Big Buck Bunny video. And we hand these two things separately to the compositor, and the compositor puts them together so that it appears like one window. And I have another variant of this illustration that shows some of the subtleties that can occur here. In this case, there's actually a control on top of the video, like the play button there. So we cannot just have the subsurface stacked on top. What we do instead is we stack the subsurface below the main window, and then we cut a hole in the main window so that the subsurface can show through from underneath, even after we rendered the button on the main surface. Right, so why do all these complications? This is it's pretty good for battery life, and it reduces power consumption. In particular, if you get those lucky circumstances I mentioned earlier, and your window is full screen playing a video, so we can get direct scan out all the way to the monitor. In that case, maybe the 3D engine of the GPU can be powered off for a very long time while you're playing this video, and we just need to do the decoding for each frame, and then we get a DMA buff, and everything works very efficiently. It's most relevant, obviously, on less powerful platforms like phones that some people like to try and run GTK4 on. But it's faster too. I mean, we just avoid doing a lot of extra work. And GTK4-based video players are actually pretty competitive now. And if you want to see this in action yourself, I would recommend installing something like, what's it called, Showtime, one of the newer video players that use these GTK4 features to the best they can. And yeah, just try it out yourself. Moving on to the actual topic of the talk, new renderers. That's the biggest piece of work that has landed since last GUADEC, I would say. When GSK was first introduced in GTK 4.0, we had two renderers. We had a GL renderer, a first generation GL renderer, and an experimental Vulkan renderer. The GL renderer was basically just good enough to get GTK4 out the door, because we had to hit this deadline. We wanted to do less than 10 years between major GTK4 versions, and so we had to release GTK4 in December before the 10-year mark. And so the renderer was just basically good enough. The Vulkan renderer never matured beyond being an experiment that we never enabled by default. For the GL renderer, we did improve it after a few releases. Christian Hurgert who sits there, actually rewrote it and made it a highly optimized piece of code, which is great for running it on less powerful GPUs. It was great for that, but it also made it a bit less extensible. It was just very optimized, and when Benjamin decided to do new renderers, he went back to the experimental Vulkan renderer we still had around, took a long look at it, see what lessons we can learn, and then he started writing a new rendering infrastructure, which is unified. That means we have like the entire abstraction of walking the node tree and translating things into commands, which calls into some abstractions that let us do either Vulkan rendering or GL rendering with the same code base. And that's nice. And some other improvements that we could do while doing all this work is that we now have more capable shaders which do anti-aliased rendering, so we can, as a side effect, actually do proper fractional scaling. And to explain a bit more of what I mean by that, I need to go back a little bit back in time. Traditional high DPI support, like GTK has been done since 2014, is just done by rendering everything at twice the resolution. So you get 4 pixels instead of 1. And of course, on your monitor, 100% might be too small, and 200% might be too big, or the other way around. And what we can then do is, on the compositor side, we can take that 2 times rendering and scale it back down so that you actually get something like 150%. Of course, that has some downsides, this approach. It makes it so that applications render more pixels than necessary. In particular, if you go beyond 2 times, say to 3 times, you end up in situations where we can actually have bandwidth problems, because that's just a lot of data, and it all gets scaled down on the compositor side again anyway. And the scaling down on the compositor side makes everything a bit blurry. It's very uniformly blurred, but still, applications really want to have the actual scale enhanced so they can render sharp at the device level. And with the new renderers, we were finally in a position that we can actually do that. There's a Wayland protocol that gives us the actual scale that the user selects, and then we can just render at that resolution without producing too many pixels. And in particular, what we can do is we can render the fonts actually at the actual resolution, so we can get font hinting that actually works properly. Before moving on, I forgot to say that there can be some problems still. The Wayland protocol that we use for fractional scaling has some limitations, and sometimes rounding errors make everything blurry again. But we're trying to get a handle on that. Beyond these big headline features that I listed now, there's a few smaller things that have happened since last GUADEC. I wanted to quickly go to some of them. One is we have a new GTK print dialog. That's what the API is called, but I wanted to make it very clear that this is not actually a dialog widget. It's another instance of we have a family of async dialog APIs which abstract away the widget so that you can nicely implement these async APIs on top of platform-specific interfaces. For example, on Windows, you can get a Windows file chooser, or on macOS, you can get a macOS file chooser. And this print dialog API is another one in this family. And on Linux, what we can use to implement these dialog APIs is portals. So this print dialog will talk to the print portal. And you can view this as another way of delegating platform UX questions to the platform, as opposed to doing it inside GTK. Here it's just done via portals. Right, we also we had some gaps in our accessibility story that we closed over the last year. The first item here is that we got a socket that lets WebKit graft the accessibility tree for the web content on top of the GTK accessible tree for the Chrome. That work was done by Georges, who's also here. Thanks for that. And we also now have a accessible text interface exported that lets third-party text widgets be accessible. One example of that is, of course, your terminal, which can use this interface to be accessible and be read by Orca. We also did some small maintenance work on list and column views. Christian, again, tracked down some problems with the GTK expression implementation that caused things to be unreliable if you have more complex expressions. I don't really want to get into the details there. This was something around weak references getting wrong. It should work much better now. That should be good news for anybody having to work with lists and column views. Last thing to mention here is work on CSS color support that happened recently and was merged. We now support a lot more of the modern CSS specs around color and different color spaces, more expressive ways to express colors in your theme. And that lets us deprecate our homegrown named color and color expression machinery, which is good because we don't want to deviate from CSS as it's on the web, if we can help it, because that's what everybody knows. And this work was done by Alice as part of the SDF initiative, so thanks for supporting GTK in that way. Right, now this is the interlude. I was hoping for a curtain to come down here so I can step out and welcome you to the second half of my talk, where I now switch gears and I'll talk about some things that have not landed yet, but are currently in the works and will hopefully show up before too long. So welcome again. I'll just keep going. I talked about accessibility already a little bit, but the big news is still coming here. It's, of course, no secret that one of the major focuses of the SDF initiative was improving our accessibility story. And Matt Campbell, who was contracted by the SDF initiative, has been working on both a new cross-platform library abstraction for accessibility called AccessKit, and on new accessibility plumbing for Wayland. That's codenamed Newton, I believe. And in a status update, he recently shared that he had GNOME text editor basically 100% accessible on Windows, which is a pretty big milestone because, to my knowledge, we never had an accessible GTK application on Windows before. So that's very exciting. And I hope that the bits and pieces of this work will land in GTK and Mutter, where the Newton plumbing needs to live over the next months, and should give us a much better story. And it might also be exciting for some that AccessKit is written in Rust. So if we merge the AccessKit support in GTK, that will be our first Rust dependency. Session saving, that's one of those minor convenience features that you only notice when it's missing. Historically, session saving has never worked well on Linux as a system feature. X11 had a session saving protocol called XSMP, but it was a bit overcomplicated and never really broadly adopted by applications. So applications have, over the decades, taken matters into their own hand. And nowadays, I guess, when Firefox crashes or gets closed in some other way, we expect it to come back the way we left it, basically, because they do save their own state, and that works. It also works for your terminal, whether that's GNOME console or Pythuxis. It'll come back with the same layout that it had, except for one minor problem. Both browsers and terminals are applications where you commonly have multiple windows open, and they may be arranged side by side or something like that. And that part of the state, unfortunately, with Wayland, is not really accessible to applications, so they can't save that themselves. So if you relaunch your terminal, it'll no longer be side-by-side tiled, but those windows are free-floating and you have to rearrange them, which is annoying. And it really only, thankfully, needs a small bit of support to let the compositor save this part of the state for us. We need a protocol where an application can restore a session that it had created before and where it can give an ID to each top-level surface, so we can know which the compositor can know which state it needs to look for in its saved session. And Carlos Garnacho has been working on this. There's a small Wayland protocol that does just this and nothing else. And we have both a GTK branch and a Mata branch. With a bit of luck, we might still be able to merge this for 4.16 and have a better story for session saving. Right. The last item I want to mention here is colors. Benjamin and myself have been working hard on improving support for colors and color spaces in GTK's rendering machinery, with the ultimate goal to be able to display HDR content properly. We have been pretty heads down into this for a month or two now, so I could talk for a long time about all the complications and details of this. I'll try to give a summary without getting lost in the weeds too much here. If you want to know more about this, you can obviously find me during the conference or after, and I'll be happy to talk more about this. So what's the plan? We want to have a color space object in GTK. For some reason, it actually changed its name from color space to color state. I don't know why that happened, but it's just the way it is. And all the colors that we are passing to GSK, to our renderers, will have to be tagged with one of those objects, so we know how to convert the colors into the color space that we want to do the compositing in. The same goes for textures that we upload and attach to nodes in our render node tree. They need to be tagged with a color space as well. And that in turn means that when we are loading image data from files, from PNGs, or when we get image data from GStreamer, we need to somehow acquire information about the color spaces. All this text code, and we have written some of that already. And we are now in the process of connecting all these things. But once they're all connected, it should be relatively easy to take HDR content that we probably get from GStreamer and have it come out right at the other end, which is the ultimate goal. Another thing we can achieve while we're doing this is to allow gradients to use different color spaces. Gradients are a bit different from the other rendering we do, because with gradients we actually interpolate between colors on the renderer side. And I wanted to go into some more depths here. When doing this interpolation, using RGB as a color space is often not ideal. You can see that here on the left side. If you go from a purplish color to a greenish color, and you interpolate in a straight line with RGB, you end up crossing pretty close to the middle where it's gray, and your gradient doesn't look so good if it has a gray blob in the middle. So what you really want to do is use a different color space where you have the hue encoded as in a polar way, as an angle. And then if you interpolate in a color space like that, a straight line interpolating from between the same two colors actually goes in this circle, because we interpolate the hue, which is the angle, so we're just rotating around, and the saturation and the luminosity stay roughly the same. One interesting aspect of this is that when we're doing this in a polar color space, like on the right, we actually have a choice to make. We can interpolate, we can go the short way or we can go the long way. But if we do that, we can actually produce pretty good-looking gradients. In this example here, I'm using the OK LCH color space. The H in there stands for hue, so this is a polar color space where the hue is encoded as an angle. And you can see two gradients here. The one at the bottom, going from red to yellow, is using the short path, and the gradient in the header bar is interpolating between the same two colors, but going the other way around the circle. So that's a bit of expressiveness that we win if we do this work in that color space. Right. All of this work is currently in the process of being merged. We already have the GTK color state object in GTK main, and we are now busy connecting it to other parts of the code. Like we are adding color space support to our PNG loading machinery, and we are we're connecting the CSS colors that I mentioned earlier to the GSK renderer as well. And once all this is done and merged, we can actually show HDR content. In fact, just yesterday morning, Benjamin was on IRC and saying that he actually had succeeded in seeing HDR content displayed properly using this machinery. So that is very recent and exciting. Right, I wanted to say a few more things here about the timeline for this work. As I said, we are merging these things right now. And once it's all done, we want to change our rendering to prefer a linear color space, which is for the compositing, which is a bit of a breaking change, because if you do the compositing in linear spaces, the end result looks subtly different than what we are used to. So we don't want to do this switch at the last minute. We'll do that early in the next cycle, so themes and applications have time to adapt to that, and we can take our time and get it right. And I think that ends my tour of developments in GTK. And all that remains is to see if there's any questions. Yes, Bedard.
When can we get rid of Cairo?
You want to repeat it into the microphone? It's an important question.
Thanks. I'm wondering, when can we completely remove Cairo?
Cairo is exposed in a lot of our APIs. Like let's see. I think the main stumbling block there is things like Cairo region and Cairo rectangle, and all these APIs are kind of baked in. And currently we still have our fallback. Our GSK rendering machinery still falls back to Cairo in the end. So I don't see a realistic path to get rid of all that before GTK 5, which is still a bit nebulous. When I was on stage a year ago and talked about the state of GTK, I said, oh, we want to start working on GTK 5, and I was convinced that was the right strategy, but over the past of the last year, I showed you a lot of the work that we were able to actually do inside GTK 4. So our current thinking is that there's still a lot of development that we can do before we have to open the GTK 490 branch and start heading down the road to GTK 5. So maybe that's a bit further away now than it was a year ago. Not the greatest answer, but that is the way it is.
Hi. My understanding was that fractional scaling is only possible with an API break, so it would be delayed to GTK 5. But then it happened in GTK 4. So is there something missing? Is it like what happened there?
No, there was no API involved in this. I mean, it's really between the application and the compositor to negotiate. I mean, there's no API that we had to break to make this happen.
Okay.
I think you mentioned as part of the CSS improvements that we were able to remove like named color or deprecate named color and things like that. So do we have like CSS variable support now? Or
yes. So I said that Alice worked on CSS colors, but actually what she started out working on first was CSS variables, as you said. Okay. And the colors were only a follow-on. So we do have fully working support for CSS variables now in our theming machinery, which is cool.
And I assume that feeds into like platform theming and such, and those initiatives.
Yeah. So Alice also ported libadwaita, the theme that is shipped in libadwaita to the new machinery. So that's using variables now, but we still define the named colors for backwards compatibility because some application CSS expects them to be there. So it will be a bit of a break if we just drop them outright. So we're gonna have to keep them in place, and then come GTK 5, we can just make a hard cut and say, no more named colors, just use variables.
This is a somewhat quick response to the fractional scaling bit. There is some things that are difficult without an ABI break. For example, we tried to make text view really fast over the years, and especially in the last cycle, we did a lot of work right at the end to make, all of the fonts kind of like jump specifically to the fractional scaling grid. And in one way, that's made the fonts way more readable today, but it's created some other issues with where you scroll, where you might get a little bit of like visual distortion because we're jumping between like the nearest pixel grid as we like move through things. So it kind of gets like this little bit of jitter that for someone like me, I find it quite annoying. But for us to fix some of that is gonna take a lot of time because it's so intricate in the details. For example, right now text view lays out everything on an integer scale. So even though we're like going to render and clip to a device grid in a fractional scaling, the position of all of your lines needs to exist on a actual integer boundary. So we need to change that to using, say, like double precision or something. And to do that, we have to break ABI. We can kind of work around it by just saying like, oh, we're working on such a small number here that like maybe we can add some different API for you to interact with and kind of like deprecate the old one and massage it to seem like it's right. But that's kind of more the type of thing that I think we just need to redo all of our widget origins in GTK 5 without integers. For example, every widget today must have an origin on an integer boundary. And that doesn't need to be that way in the future, but at the moment it is.
Yeah, thanks for that explanation. I was just going to briefly throw in here that I'm giving a talk with Bedard on Saturday about fonts, where we'll probably dive a little bit into some of these topics around GTK's font rendering.
Okay, we'll take this last question.
Yeah, I guess I could have looked myself, but I'm assuming the CSS is all in-house, the implementation of CSS?
What about it? Sorry, I didn't catch the question.
Is it all implemented in GTK?
Yes, GTK has its own CSS implementation, which has been in the works for the better part of 10 years now, I guess, and it has over time matured, and as we just saw, like now it even supports complicated features like CSS variables. So it is obviously never going to be as complete as a web browser's CSS implementation, but it's decent, I would say, at this point, and certainly good enough for our needs and themes. Okay, so there's no, I'm assuming the use cases diverge. There's no, you were talking earlier in the talk about outsourcing a lot of the stuff to other libraries. Is there space to do that with CSS, or it sounds like it's a very specialized use, so there isn't really any point in that? Yeah, it's a bit different from the way you use CSS on the web. I mean, we are explicitly not doing layout with CSS, so it's just about backgrounds, colors, borders. And yeah, it's its own flavor of CSS, I guess. And so, but you're right, from that perspective, it might, I talked about the code base being too big, so you could argue for maybe we should just use some CSS implementation from somewhere else, but I don't know, that will be work that somebody needs to do, and so far what we have works and is maybe small and focused enough that you can actually do things like Alice, who came in and became familiar with our CSS code base and then implemented CSS variables within a few months, which is not a small feat, I would say. That was a scary spec for some of the people who have worked on CSS before. Yeah. Thanks.
Thank you.
All right, just one last sentence. I wanted to mention that the slides and the materials that I used here are available on on GitLab if you want to find them. Thank you.
Can you hear me? Okay, so I'm going to be talking about a new SDK we've been working on at Igalia to make developing WebKit GTK a little bit easier. So the agenda, I'm going to cover some of the pain points of working on WebKit GTK, the many ways that we currently have to build GTK, and go over some workflows using the new SDK. So WebKit GTK is a bit unique in the GNOME ecosystem in that it's a large, modern C++ code base. So unlike most of GNOME, you need a compiler that's very recent, and there's this complex matrix of compilers and C++ standard libraries that you can mix and match, and they all support different versions of the language. We have a relatively complex CMake build system. We don't use Mason, unfortunately. And we have a lot of dependencies. We depend on most of the GNOME platform itself. We depend on GStreamer, including very specific versions of GStreamer and very specific decoders in GStreamer. We have many build scripts over the decades that have built up in Perl, Python, Ruby. So it's a bit complicated until I get it set up. So the most straightforward way of building WebKit is of course, just building out in the host. And we have a script to install dependencies. But this will only work on a few distros that we actually test, very up-to-date versions of it. It installs a lot of packages that you don't necessarily want. And a few dependencies we have that we use during development, like libbacktrace, aren't actually packaged anywhere. So in order to get around this, we use JHBuild historically, which many GNOME developers are familiar with. But that kind of just moves the problem. You still have a limited number of hosts that are supported, but now you have to build all these dependencies on top of it. So it's not very reliable. People can't reproduce it on their own systems. So a few years ago, we switched to Flatpak, which is a huge step forward. It's finally portable, reproducible. But in order to do this, we had to maintain our own Flatpak runtime, which is quite complicated using Buildstream. This leads to new problems, though. Since you're in Flatpak, you have limited tools. You can't install any tool that you want. It's a read-only runtime, so if you want to install libraries, you can't really do that. And it's a sandbox meant for running applications, not really for development. So it didn't quite fit our use case that well. So some things that we wanted a new solution to resolve is that we wanted all traditional development tools to work. We don't want you to have to work around our solution. We don't want to maintain our own runtime or anything like that. We want to keep some of the good aspects of solutions like Flatpak, so we want it to be reproducible, but we can do better than Flatpak. It's not very good, or our current solution wasn't very good at maintaining multiple versions of the runtime. And we want to be able to develop both libraries below WebKit and applications on top of WebKit. So our new container solution kind of implements the strengths of all those approaches. We use Podman, so we still get a container. But for the image, we just use Ubuntu. It has long-term support. It's very common. People understand it. And we continue to use JHBuild on top of that because it's quite useful as a developer tool for building things, which we'll get into. So the basic usage couldn't be more straightforward. You just clone the repo and add it to your path. We have a script that creates a new container. You can create as many containers as you'd like. And then you enter that container. Once you're in the container, you just build WebKit. Everything's there. Everything works as expected. It's under MIT license. You can check it out there. So what we do is we provide a few scripts that you can run on your host. So there's scripts to create containers, to run shells in containers, to delete and recreate containers when new versions come, and to build images locally if you want to customize it. And then inside of the container, we have a few scripts that just help you a little bit, like setting up dev help to read documentation for your current developed version. And we have a script that installs Visual Studio Code and some extensions along with it. So this is kind of our recommended workflow for developing inside of the container. As it's just an Ubuntu installation, you can use any tools that you traditionally do. But we highly recommend Visual Studio Code with these extensions. It's what we use internally, and it works quite well. Whatever editor you choose to use, we recommend ClangD for the C++ integration. And the main reason for that is that WebKit does this complicated build system solution called unified sources. So what it does is it combines like 8 source files into one source file at build time, because that reduces the number of files you can compile by 1/8. So it significantly speeds up compilation time for such a large code base. But this breaks any tooling, basically, because the list of source files no longer matches the real list of source files. So very recently, we've added some scripts that expand out these files back into the correct ones. But it only specifically works if you use ClangD currently. Any other tooling will need to manually handle this. And we also recommend LLDB instead of GDB. GDB will work completely fine, but WebKit has a large base library, and it doesn't necessarily use the C++ standard library for everything. And Apple maintains a LLDB script that adds type information and formatting for things like strings, hash maps, bit masks, and things like that. And you can simply import the script when you run LLDB. And so here's an example of running it under LLDB. As you can see with the new value variable, it shows that it's a string. By default, you would just see basic structures. And everything works in LLDB very similar to GDB that you're familiar with. Another complication is that WebKit is multi-process. So a lot of editors and tools, when the debugger attaches to it, it just attaches to the main process. And that's not very helpful, because most of your development is going to be in the web processes or the network process. So you really need an editor that makes it easy to do this. In WebKit or in Visual Studio, it's quite a simple drop-down where you just select the process you want to attach to. Unfortunately, the configuration for that's a little bit manual, but you have to list the processes that you want it to attach to. Another complication is that WebKit has a lot of build scripts that expect things to work in a very specific way. So we have a script that calls CMake for you with all the flags and the build directory that it expects. And other scripts like run WebKit tests rely on a lot of these assumptions, which is complicated when you use an editor. But CMake has this really useful feature called presets. So if you run CMake with the preset of like GTK debug, it'll pass all the flags you need and use the build directory that it expects. So all the scripts work normally. And in Visual Studio Code, it just has a drop-down where you select whatever preset you want and handles everything for you. And we continue to use JHBuild. It's maybe not the prettiest tool in the world, but it's quite effective for what our development workflow is. So we include a module set that has all of the popular GNOME projects like glib, libsoup, Epiphany, GStreamer. So these are things that you'll regularly build. Here's an example of building glib. We always put it in the checkout directory. So you can just make changes there and then reinstall it to easily test different glib versions or patch glib. Running Epiphany is also a really, really good way of testing WebKit, which is quite tricky to do with Flatpak before. So as long as you install WebKit into the JHBuild prefix, it's just two simple commands to build Epiphany on top of the development version of WebKit that you use. And so that's basically the summary of our development workflow using this new SDK. There's one minor addendum. A week ago, these ClangD changes worked. This week, those ClangD changes don't work. Next week, the ClangD changes will work again. So there's a pull request to fix these things. And that's basically all from me. If anybody has any questions.
Hey, ClangD stuff. We have support for it in Builder, but we don't enable it by default. Do you think we should be switching to ClangD? That's one of the first questions. And the other one is for the drop-down processes. Does the LLDB stuff connect to all of the processes up front, or will it connect to them when you select it from the menu?
So regarding ClangD, I mean, your complaints about ClangD are completely valid. Maybe you could auto-detect that you're developing WebKit and just use ClangD for that project.
Cool.
So for the processes, if you're on Mac OS and you use Xcode, it's really nice because it automatically detects all of them and connects to all of them. Visual Studio does not do that. You have to manually connect to them each time.
So that means like if they break, you just automatically get a breakpoint because they're already connected in the background?
You will have to connect ahead of time.
Okay. I guess I was curious is like what we would need to do from the automation standpoint. Like we can follow the process tree and show you all the processes and then, but it's like to make you connect to them, they need, you know, like that parent debugger process. So do we have some sort of hooks that will go in and start the superior process, or I'm just curious, I guess, how LLDB is going about making sure it has access to these.
I mean, if I were adding this to Builder, I would honestly just hard code WebKit. I feel like it's a very specific use case,
yeah.
And I assume that's what they do in Xcode. I don't know. It's kind of tricky to follow all the child processes because they're not like direct children.
Yeah.
Like it launches a new sandbox and it's a separate process tree and everything. So I don't know how easy it would be to automatically do that.
Okay. Well, anyway, if you figure out how they're doing it there and write it up, you know, we can certainly change the architecture to accommodate it.
Mm-hmm.
When you write WebKit dev setup VS Code, are you installing it on the host or in the container?
So all of this runs inside of the container.
Okay.
One of the goals of this container was a big problem with Flatpak is that all of the tools had to adapt to Flatpak on the host. So the strategy for this is you just install your tools in the container and they don't need to understand anything about containers.
Could you run it on the host and SSH into the container to develop it, or are a lot of the things not going to work then?
Yeah, you don't even need to SSH in. We have, if I can find it. So the enter command, you can simply pass commands to run. So you could wkdev enter -- command clang or whatever, and it will, on the host, run a command in the container. So I guess that'd be similar to like how GNOME Builder runs things inside of containers. It could have specifically support for our container solution if it wanted.
Cool.
So I guess first to quickly say something to Philip's question about running VS Code in the host. We do have something called Toolbox VS Code. It's a fancy shell script that hooks up VS Code on the host to a toolbox and uses Visual Studio's remote containers extension. It actually works really well, but so if you're interested in doing something like that, you can look at that. You sort of forget that you're actually not doing things inside the Visual Studio actual, like inside the SDK or whatever. It just sort of pretty seamlessly hooks to a toolbox. So I guess my question was, so I mean, you clearly created your own custom solution there. And I'm wondering if you looked at things like Toolbox, DistroBox, Dev containers, and do you think there could be things done to, like, say, extend Toolbox so it could be used instead of doing this custom, or is it basically inherently custom because you're just too complex and WebKitty?
I would say it's the opposite. What we want is actually more simple than all these other solutions. These commands basically wrap a single podman command. We didn't really see value added in all these tools on top of podman. They're very small, simple bash scripts. And how we use podman is we disable basically all isolation that we can. We don't use it for security reasons. The only thing we isolate is your home directory, so it doesn't, dirty up your home directory. So it is the most simple way of just starting a container that has its own dependencies.
Okay.
Like you can even run like Flatpaks and stuff inside of the container, and it will integrate with the portals on the host and everything. Our goal is to be as close to the host as possible.
Okay, I mean, it seems like that the sort of overall goals are pretty similar. I mean, you don't have a lot of isolation with Toolbox either, but you're saying you went with a different approach because you thought it would work better for what you were doing. Yeah. Okay.
I mean, Toolbox is a good project. It's replacing 100 lines of Bash with thousands of lines of whatever Toolbox is. We didn't see the value of that complexity.
Yeah. Well, obviously, the value you get to if we could have things that make it easier to create solutions like this, that is that people have less learning to do, and things like integration with VS Code or whatever could be shared across different projects. But that's always easier to say from sort of a general, oh, that would be nice if it happened, than I actually want to get something to go and work today type approach. Yeah. Thank you. And it's very interesting to hear it sounds like you're really making things better for WebKit developers and easier to get involved in it.
Are there any more questions? Yeah.
More of a comment, but I feel like we should take some of the free BOF time and do some sort of containerization chat. Because I find it very interesting, like the toolbox, between this toolbox and everything else, it'd be cool to share and learn from each other on how people are containerizing their dev workflows right now.
Okay. Yeah, thank you so much.
Thank you.
You're always breaking GNOME. So take it away. Is the mic?
Oh. Yeah. Oh. Okay, keep talking, Jordan.
Oh, can we start? Oh. Hello, everybody. I hope you're always breaking GNOME talk, which the title is a bit misleading because during the talk we figured out that we'd rather talk about all the exciting GNOME things that happen in GNOME OS, but it started originally as what happens and how we actually build GNOME and why you always break it. But in order to do that, in order to build GNOME and test it, we have GNOME OS, which is well, the slides will gonna yes.
Big
okay.
button.
So we have GNOME OS, which what GNOME OS is an operating system distribution we use to test GNOME and figure out when things, how are things working, if they are working. That is, it's an independent distribution. Well, it's not. It's an operating system. It's distribution independent, meaning that we do not base it on Ubuntu or Fedora or anything else. As GNOME has to be vendor neutral, and we don't want our tooling to be specific to any distro. We want everything to be we want everything to be, independent and functional, and make sure that things will work regardless of the system you are on. It's built from scratch. We'll see later. It's based on Free Desktop SDK for a lot of things, but everything is built from scratch, from the kernel all the way to the user phase. It's as much reproducible as possible, and this is quite a really nice property to have in a testing system, because we have a lot of bugs, but at least they're reproducible bugs, and we know about them. And it's very experimental in the sense that we do not make any stability claims, and from time to time we might break your system. So yeah, we also transition from technology to technology. For example, the latest things we will see about today are about all the new and exciting things that have to do with security and redefining how we compose an operating system. GNOME OS is mostly for developers, designers, in order to build and test their changes. So, for example, developers often need to have newer versions of glib or GTK or anything else when they're testing their things. And GNOME OS builds everything from Git and as latest as possibly we can. It's also for designers, so designers no longer have to mess with how they build something, how a component is, how you need to compile a program, an application, the shell itself. They can just boot up the virtual machine and see how things are progressing, or what landed, what needs fixing, what's broken, and all that. We also use it for marketing purposes. As you see in this screenshot, it's like a screenshot of the 47 alpha release we did a couple of days ago, which obviously it's not out or anything, but we take material out of it for the release video. We take screenshots. We can eventually we hope to have a press kit at some point. It's also for people that want to test things, and anyone curious enough that wants to hack around on operating system itself and see how it's built. What GNOME OS is not is a general purpose operating system, as its scope is mainly for development and extremely limited. And due to that, there are a lot of things that are missing. A lot of things are not stable. We might eat your work. Your machine might stop booting. However, we try very hard on making that as recoverable as possible, and we're looking into building the operating system in a way that's as recoverable. So even when things go wrong, you have such guarantees that you can easily get back to a working state. And at the moment, it does not have a security team, as it's like it's a very, very small team of us that maintains it. And we are mostly interested in like trying to have everything working at the time, and there is nobody like looking after security updates, CVs, and all that. As we do not expect people will use it on for real work, or rather for certainty work. How we build GNOME OS now is another question, because it has to do a lot with the GNOME release team, which is in charge of keeping GNOME building, which sounds easy, of course, like think software will like build itself, but when you talk about like 200 plus modules that make up all of GNOME, things can very, very easily go wrong if one module stops compiling for whatever reason, or there is like a big transition that we might need to do and land a couple of things at the same time. The release team is there to make sure that everything keeps compiling. So whenever you start compiling locally yourself, everything will just work, and hopefully you will never have to see a weird build failure like you used to when with GHP and all that. That also we also like use that when we create releases for distros to pick up. We need something that to make sure that all the components, all the releases, all the latest tags will work together one with another. The release team uses the repository linked here, which is GNOME build meta, and it's a lot of build definitions and the sources that we use for its build. It's a build stream project, and with that come a lot of different things we take advantage of. And it's a quite flexible tool, because from that repository, we both create the releases, we make sure everything builds. Additionally, we build the Flatpak runtimes from that, and GNOME OS itself. So everything is built from the same sources, the same binaries. We have like a nice content addressable server of all the builds. So builds are pretty fast, and we don't have like to rebuild everything every time. And there are like a lot of future plans we have for that as well. In addition to like the Flatpak runtimes in GNOME OS, eventually we want to like publish the SDK, the runtime documentations, or check for ABI breakers. Or another idea we had at some point was exporting all the JavaScript introspection definitions somewhere, so bindings could consume that from the canonical source or other things like that. But yeah, all that's our future plans. So GNOME build, as I said, is a build stream project. What happens is that we have like basically an element for almost every project that makes up GNOME core, that is, and we try to track the latest change we can. So let's say every day or so, or maybe twice a day, we will check, we will pull down all the changes on GTK, on glib, on Cairo, or whatever. We'll try to build them. If the build succeeds, it automatically gets deployed. And we push out the Flatpak runtime, and GNOME OS builds that way for others to consume the nightly builds. This is the part that always breaks and the source of the talk. But yeah. Additionally, from the same exact repository, we also manage stable releases, where instead of like pulling everything from Git, we just pull the latest tarball release or the latest tag of its component. Again, test them, build them, push it. All of it is based on Free Desktop SDK, which is part of why, because it started off as just building the Flatpak runtimes, which were at the time that, and then we said, oh, well, we can just use that for GNOME OS as well, because we can totally just build an entire operating system with that. Even though it's like just like a base for the Flatpak runtimes originally, it can be easily extended like that. Our team is very small. It's basically the GNOME release team, which is like a handful of people that keep track of all the things in GNOME that needs to be updated, and all the modules, and fix all the build failures and all that. And additional to that, we usually have there's Valentin and Adrian who take care of how GNOME OS itself is put together and composed, and the source of a lot of the changes we'll be discussing later. Sam as well, who takes care of the OpenQA. And yeah, we also, like the release team, takes care of a lot of the CI that we create as part of these things. And yeah, that's about it of GNOME OS. And with that, I'll give it to Valentine for the general updates on how we composed GNOME OS itself.
Yes, let me fix the presenter. Yes, so the big thing that was new in GNOME OS since last year, this is the move from OS 3 to sysupdate. So since 2019, we have been using OS 3. This is to deploy updates to your installation of GNOME OS. And it's been very useful and worked very great. So we had an atomic distribution. So could just every time there was a new build on master, it could be deployed on your machine at once without big problems. But we have for a year we have been testing sysupdate, which is a tool that comes from systemd, and OS 3 is great, but the fact that it's a different tool from systemd, and systemd has all its tools are moving ahead together. Using OS 3 together with systemd has some limitations. There was a few things that were not working like we wanted, and because we had to wait for OS 3 to catch up. But because we are not a distribution, we are a operating system that is bleeding edge. We want to use a lot of stuff from systemd, so it's moving to sysupdate was good for us. So I hope we will drop OS 3 so we don't have to deal with two different deployments, but we'll see what happens. So systemd sysupdate comes from it's a part of the IDE that in systemd they had. Lennart has published some blog post about that, about how a modern image-based Linux should be. And the big points are you have an AB partition and you need to be able to update. So this is very simple way to update. So you just have a /user partition somewhere, and when you want to update, you have another partition on your disk that will receive your update, and you reboot and switch to that. This integrates, everything integrates very well with systemd boot, and there is something new which is like called the unified kernel images that we have been able to use now, but we were not able to use with OS 3, which is a signed EFI binary that contains the kernel, but also the uniform FS and a lot of metadata. So we don't have to care about boot entries to in the bootloader, but only just drop one kernel file into the bootloader. And along with this, the distribution. So we have a distribution of unified kernel images, but also DDIs, discoverable disk images, which is a generic way to have an image that we know what to do about how to mount it and everything based on itself. So everything now with the sysupdate version of GNOME OS is distributed in one of those two formats. And all this came with measured boot. So on your computer, you have a TPM, which is a small device for security that can do wrapping of keys, so it can encrypt your keys. And this can be used for full disk encryption. So the idea, systemd unifies a bit all these different things with all the tools that are available there. One of the things that we had in OS 3 that was very useful was to have branches. So we had two flavors of GNOME OS, which were built together, but we have what GNOME should be, and then we have GNOME with all the development tools that a GNOME developer will need. So that was distributed as two different branches. So you could switch from one branch to another and reboot with all the development or not. For the world of sysupdate, that doesn't work very well because the development is quite big and you need to store that in a raw data partition and not this in a small partition because of the AB partition thing. So for that, we have used another tool that came also with systemd, which is called sysext, which is a way to overlay extension to your file system. So when we build now, we build the user partition as a normal partition, and then the development tool will put it on the layer, and we distribute that together, and the installation of GNOME OS will download whatever it needs. And right now, the sysupdate version of GNOME OS, we do have secure boot working with a signed boot chain. So we use custom keys, of course, because this is a development project. There is no we don't have security team, so this is not signed by Microsoft keys. So if you want to use secure boot, you have to enroll your keys on your computer, which is not a very difficult thing to do. And the /user is the mverity, so the root hash is embedded in the UKI that is signed, so we know that the whole boot is secure, because when it has booted, we know that everything that has booted was coming from a build that comes from RCI. And with this, we have the transparent full encryption that, so on the first boot, it will create the partition, encrypted partition for you. It will do the encryption, and it will seal with the TPM if there is a TPM, and you will never have to care about it. You might have to enroll recovery keys so you don't lose your data if you change motherboard or something like that, but that's it. And we do have our sysupdate images are deployed. So this is a very simple thing because it's just the HTTP servers that we needed. So it goes with a CDN, and so you do get, if you have sysupdate version of GNOME OS on your machine, you do get updates directly from master. There is still some rough angles here. The deployment of sysext is still a bit broken, and it's hard to discover how to enable the development extension or other extensions. So there is some work there, but there is some agreements and some work that is going there, so it's a good thing. We are missing in the big picture of this new modern distribution. Systemd Homd is used to deal with home directories, and even though we have that thing because we have systemd, it's like most of distribution, you have to do it manually because it's not by default. So there's more work there. The installer is also a mess because I've done that a long time ago and we didn't change anything there. It was using the Endless OS installer, which was great for the time, but now there are things in the picture that we don't have. For instance, how the ESP is created, it doesn't do anything there. The good news is that the funding from the SDF will solve some of this problem, and some of these are already worked on. There's Adrian and there's people from Cutting as well working on these kind of things, and I'm looking forward to next GUADEC to see all the cool stuff that will be there. I don't work on these things personally. Yes, and of course it's still run on hardware, so I do run every day GNOME OS on several machines. So when you break GNOME, I get after a few days it breaks on my machine, so I know about it. So as always, we expect UEFI computer, so the old legacy boot doesn't work. This is not portable anyway, we don't want to care about those kind of things. This is out of scope for our project. So we mainly test on AMD, but the sysupdate it works on ARM and on RISC-V. So there you probably need some tweaks, but I did manage to get it working on hardware. I think the ARM is actually even published, so it's there, but I don't think anybody really uses it. There are things that remember that we don't do multi-OS on the same disk because this is a mess. If you want to have multiple operating system on your computer, you probably want to have several disks. Something important that I want to You say that because we maintain our own kernel configuration, which is in free desktop SDK part, but it's still a part of the GNOME OS development. Sometimes some people don't manage to make it run on their computer. Most of the time they have no problem, but it doesn't work sometimes because there are some maintaining kernel configuration is not that easy. So I would like some help. So if at some point you want to test GNOME OS on computer, don't install it because it's the development thing. But you should probably boot it from a USB to tell us what's not booting and what's not working. That's very nice. Also, during the year, there's new things. Proprietary NVIDIA driver came as extension, and that works. The experience is maybe not the best, but it's just important to have a way to be able to actually test GNOME Shell on this kind of drivers. So we have that there. I think there is one person using on their computer, so it must be working still because I'm not using it anymore. I just made it work and then it's away. We talked about secure boot, and I really want to make sure that because that might be scary for some people who don't like this thing about secure boot. Because we use shim, you can put your own keys and make a local build and switch to your local build. I do that quite often to test new things on my machine. So this is the kind of, you can have control of the computer. You don't have to rely only on RCI. And you can do the opposite where you can actually have your own keys and only build locally. Yes, and I think that was my part.
Hello, yes. Now we're gonna move on to like how to use GNOME OS for hacking and other things in your project. Thank you very much, Valentine, for the update. So GNOME OS is very, very far away from the traditional Linux distributions of today. It's an immutable OS. It has been for ever since it started. And due to that, a lot of workflows do not apply to it. Like, you can't easily, nowadays you can, but it's the usual thing where you mention install something on your user and the launch things to try that is not going to work as is. We also have no package manager or like anything package for it. So a lot of utilities you might need that are not yet in the development tree. We try to add most of them like that are useful, like Valgrind and ASN and all those generally there, but you might need some to compile from source, some tool that you might need for a specific task to debug. So a lot of these are will not be there. However, we are working very hard on like figuring out decent workflows to make testing system components much easier, and our aim is like make it as easy as with this with Flatpak today. You can also like build your own version of GNOME OS with verified boot and measure boot and all that, just like we do on the CI and have like everything. However, that takes a long time because you have to compose the whole image. So it's not ideal for day-to-day development. It's mostly like just to make sure that a change we made actually is 100% working. And for other things, we usually use a faster iteration loop. What we have right now that works is either building against your host system or a toolbox image, I guess, and then using that binaries in the host system. Usually, when you have a read-only operating system, they do not give you all the development tools, the tool chains, the headers, the debug symbols, and all that. So your host system is useless. However, in GNOME OS, that's not the case. You have a development tree, or rather development with sysx, that will provide everything that's in the system and image. It will provide all the counterparts in the headers, the debug symbols, and it will give you all the compilers we use in order to compose the system. So if you want to build any GNOME project, usually you don't need any external dependency. Everything can just be built against the host system, then you can test it against the host system. However, there are like some cases where you want persistent changes. And with a read-only user, with an immutable, or rather, I should say, operating system, that's not easy to do. However, thanks to systemd again, we now have a tool called systemd sysext, where we can like create an image or plain directory even. So you can like meson install into this specific location and add a metadata file. And once you, on the next boot, or you can, or once you ask system that is, the whole user tree atomically, and your new changes will be overlaid to the current system. That means you can have your persistent changes with an immutable system and keep development like you're used to right now, mostly. And that is like an extremely fast and efficient iteration loop. And that means, and since it happens so early in the boot chain, it means we can test and debug almost any single module in GNOME, from GNOME session and GNOME shell to applications and libRwata and all that. As part of the SDF command again, Martin from Coding has been working on some tooling to make working with sysext and creating images out of them a bit easier for our workflows. So we have a new tool now that can create sysext image, or rather DDIs from that we fed into sysext from Meson build directories or from build stream itself. So you can either you have your custom checkout of the project and you configured a certain way, and you want to just make an image out of that and feed it into a virtual machine, or you want to like replicate exactly how GNOME OS builds GNOME shell, for example, and take just a different version of it and deploy that into the VM. And you can do that in very trivial way. Another reason we made these utilities and drivers so we can have the CI view. So a couple of months ago or year, I started making CI images out of the GNOME OS 3, much like we have for Flatpak nightly, which means that you can have available the user tree in a Docker image that we can directly use in CI, and then you can like make a sysext, build a sysext against that image, and then you can just take that sysext image and feed it into the VM. Ideally, we will have a GNOME simulator that we would have in Builder, and everything we develop against that, much like we do with Flatpak runtime, and then you would directly be able to learn to use whatever host operating system you like, but develop and run against the GNOME OS, but that's not there, but that's the end goal. So for module development, you can grab the latest GNOME OS image, you can put it in boxes, you can install the sysupdate variant, which is this thing at the moment, since we currently have both OS3 and sysupdate for the time being, until we figure out all the edge cases. You will need to enable the development, the debug extensions to have the headers, but otherwise you should be good to go. You might need to compile some tools, as said earlier. And the idea is that you build against the host system and use sysext utils to create the image you need and do whatever you want with that. I have a demo afterwards to run to show you again how it works with CI. But yeah, and you basically the system keeps itself updated with updatectl and systemd. And yeah, you can install Flatbox as needed, or use some other Podman toolbox and other things like that. So for the demo, it's a 1-minute demo. It's going to be long, and then.
What about we continue with OpenQA and then we show the demo after Sam has.
Excellent idea.
Yes.
Take it ahead, Sam.
Okay. Let's talk a little about QA then. So you guys can hear me. Can Valentin, Jordan, can you hear me in Berlin? And I guess they can't. If I turn on the microphone, is everything going to catch fire? No, that's okay. Okay, so you guys can hear me now, I think. All right, I want to talk a little bit about QA, one of the big motivations for building GNOME OS is that we can test things as fast as we can build them, right? So if we wait for distros to do QA on the things we release, we have to make a tarball, and then they have to package it, and then we get a bug report 3 months later. Much better if we can build an operating system straight from master and test that. But of course, manually testing things is very boring, right? Who likes manually testing things? So we've been looking at how to use OpenQA to test stuff for us. Who's got the slides? Next slide. Maybe I can change the slide. Am I the presenter? Yeah, I think so. Right, I clicked the little arrow. Okay, this is great. Actually, I'm going to play a quick video. I don't know if this is going to come across on the... No, I think this will come across on the screen, right? So this is the OpenQA instance that we have. This is an example of a test. And you can see all the screenshots that it took. And I'm just going to play... One cool thing about OpenQA is every time it runs a test, it records a video. So all going well, we can watch the video of the GNOME install test. And here we go. So this is a real virtual machine. It's running the GNOME OS installer. This isn't real time, by the way. Reboot the machine, run through initial setup. The shell booted, so the test passed. We shut it down, and everything's great. And as well as the video, we can see all of the journal output. Well, actually, that isn't there, but usually we have the journal output in the serial console and other stuff. So if something goes wrong, you can kind of see what happened. Let's see. I'm not going to go into the details of OpenQA because I don't have time. Please ask me if you're interested. And there's also a talk I did last year which goes into a lot more detail. Great tool. Thank you to OpenSUSE for a lot of the work that they do on it. One really cool thing that's happened over the last year is we've set up a monthly call between different distro QA teams and basically anyone interested in testing desktop Linux. Anyone doing automated testing of desktop Linux. So it's not specific to GNOME, it's not specific to GNOME OS. And through this, we discovered that 3 distros are already doing OpenQA. So OpenSUSE, of course, Fedora also have a huge suite of tests that they run every day. That's actually a screenshot from the Fedora test suite, and they're testing all of our apps and more. And then Debian are also running tests 3 times a day. So this is fantastic. And you can join the call, by the way. It's open. So stuff that's happened in the last year on the GNOME side. We ran an outreach internship. That's Dorothy and that's Tanju, who are interns from December to February of this year. They added some more tests around apps, resizing to mobile form factor, and around some of the accessibility features. Still plenty more to do on that. Again, talk to me or someone else if you have ideas on more accessibility stuff we can test. We also hit a rather annoying bug in GNOME Shell that causes tests to randomly fail, which isn't resolved yet. We think we might have a good workaround, but that's making everyone sad because tests aren't fun when they fail randomly. And there's been a lot of work recently thanks to a grant from the STF and some co-sponsorship from CodeThink, where we've been doing work on GNOME OS, and we've also been working on how to test modules with OpenQA. Because when I ask module maintainers what they think about the OpenQA instance, they always say, well, that's really good, but I don't want to test stuff after I've merged a branch, right? I don't want to merge to master, and then 2 days later you run a test, and then the PR was bad. I want to run the tests during code review. So we've been looking at how to do that. I'm going to have to summarize this again because we're short on time, but the answer basically is systemd sysext. So rebuilding the image every time you make a change is too slow because it's a 5 GB operating system image. But you can build a sysext, and you can overlay it on the base OS that was built, today or yesterday, and then you can test your latest unmerged changes from layered on top of the OS base image. And Martin, who's unfortunately doing a talk right now at the same time as this one, but ask Martin or ask me if you want to find out more about that, because there's some really interesting stuff coming up. And on Monday, there's also a workshop. It's going to be a local and remote workshop talking more about OpenQA testing. So again, I recommend attending that to find out more. And I think that's everything from me. Do we want to go back to the demo, or do we want a couple? How much time do we have? 3 minutes. So we can choose demo or QA, I think. Demo. Everyone here is saying demo. Is that all right? I think I'm going to have to make Jordan the presenter again, though, right? Okay, you're the presenter now, Jordan. You've got...
Thank you. Well, while we were waiting for the questions, I guess.
I'm going to show the chat as well, since we're here. I know.
All right, I'm not sure if you can hear me still, but here's a video of the demo, which isn't very sweet for the users. The thing, here is a GNOME OS VM, because I was going to do it on my machine, my laptop, but I couldn't figure out how to capture it. The thing we will have to take a better attention here is how light the font is here. Sam made a merge request for the GNOME shell to recently change a bit the weight of the font on the lock screen. And the CI CSX bundle that using the CI image and CSX details and all that we created, and we may also paste in the log one-line command that you can just copy into GNOME OS, and then it will automatically download the image or overlay it on the system, run a couple of integration commands if they need to be, and afterwards, once you restart JDM to reload the new by the new session from the new user tree, you will notice that the clock on the lock screen is now much more has a much bigger, it's much heavier now, which is awesome. So because designers always were asking, oh, how can I test something, merge request something without having to recompile everything and recompile WebKit because some things are depending on the newer version or whatever, just in order to test cell. Now we have like a process that's almost as easy as Flatpak, basically. And yeah, that's it. Any questions? Some you would have to repeat the questions to us.
Okay. Do we have any local questions? Remote questions? Nothing here. I think everyone's keen for lunch. Okay, well, thanks a lot for this. This is a milestone, right? A hybrid presentation between Norway, Berlin, and Denver. Thanks a lot for being a part of it.
Excellent.
Damn.
I'm going to start the presentation, Hadi, so I'll let you know when you should start talking, okay?
Okay.
All right, so thanks everybody for coming. As always, my GUADEC talks are scheduled right after lunch, so there's always the risk of people sleeping or not coming whatsoever. So I really do appreciate people who actually came here. My name is Georges. I don't think that's a surprise to anybody. Today I'm going to be talking about calendaring and the modern desktop, which is a fancy title for something that I'm not sure is a fancy subject. I'm also going to be talking about it with the help of some contributors to GNOME Calendar, some maintainers including, because Calendar is one of the few core apps in GNOME that has more than one maintainer, or for the matter of fact, more than 0 maintainers, so we're in a pretty good spot. We also have Hadi, Rana, and Jean-Francois, Jeff. We are supposed to have Jeff. Jeff still hasn't popped up, so I really hope that Jeff comes in time. So yeah, let's begin. So today we're going to be talking about calendaring. It's mostly about GNOME Calendar, but it's not strictly about GNOME Calendar. There are many interesting facts around calendaring that some people call it a curse, but I want to share with you because nothing better than sharing a curse with others, so everybody's cursed together. If you made it to this talk, then probably things worked well on GNOME Calendar side. I'm going to give you all a very, very, very brief overview of how the whole thing is put together. And the side note is that it is all lurking on the shoulders of one guy in the Czech Republic, as things always happen. We basically have one massive service, Evolution Data Server. I don't think that's a surprise to anybody. What might be a surprise to lots of people is that Evolution Data Server is bigger than GTK and bigger than GNOME Builder. And it is, I think, the second biggest code base in the entirety of GNOME. And that's just for calendaring and emails. Calendaring takes 2/3 of it, so calendaring is probably the biggest feature in the GNOME desktop. Maybe that's, it's hard to come up with fancy comments for this because it's such an underrated thing. You just put events and you show the events, and it's easy, right? Well, it's not. Let's go through this. For GNOME Calendar, we just delegate everything: database, fetching calendars online, security, TLS, authentication, web call, call dev, card dev. Everything is just handled by Evolution Data Server. GNOME Calendar just consumes that in a fancy form and makes it look a little prettier than Evolution, which is another consumer of Evolution Data Server. GNOME Shell also consumes from Evolution Data Server, so we can add events in GNOME Calendar and they show up in your GNOME Shell. It's cool, right? And yeah, Evolution also uses GNOME Align accounts to set up some automatic web dev stuff. When you add your Nextcloud thing or your Google account or your web call URL, Evolution is going to automatically pick that up and use that for your calendaring purposes. And I really have to rush. There's too much to cover here. So what does GNOME Calendar look like right now? This is also probably not a surprise to anybody. Recently, we had probably the biggest feature in the history of this application, the infinitely scrolling month view. And it's super cool, but also super difficult. The fact that it's infinite means we cannot use any kind of time-limited or bounded widgetry like GTK adjustment or GTK list view or GTK list box or anything like that. So it has to be, everything has to be custom. And we do a lot of work to make it look like it's infinite. So you can just scroll up and down, left and right, and things are just going to work. It's pretty fancy. As part of the mobile enablement of the app, we got a sidebar a couple of years ago. Still have mixed feelings about it, but apparently people enjoy the looks of a sidebar-based application, and here we are. But I'm not here to talk about how GNOME Calendar is awesome. You all know that. But I want to talk about the difficulties of developing a calendaring application and the hidden secrets that we have to keep everybody away from for their own sanity. 352 pages of RFCs to memorize. It's not fun. We got fantastic little details. Has anybody heard of leap seconds? Has anybody ever heard of the day that the American government decided to add an extra second to a random day to make some kind of military budgeting work? Has anybody ever heard of, I don't know, the Uzbekistan government deciding that the next day was going to be a daylight saving time day and just flipping it over overnight? Yeah, this is the kind of thing that we have to deal with. Calendaring is essentially a political thing. The planet Earth doesn't really care about how we divide days. It's going to keep spinning on its own pace, regardless of how we organize that spinning. We have moon cycles, we have year cycles, we have 3,000-year cycles, we have 15,000-year cycles, and some only parts of that are encoded in our calendaring. Yeah, we can show a map in GNOME Calendar because that's apparently a source of many heated debates over the past 30 years or so. We can show flags in GNOME Calendar because that's also apparently a source of heated debates for many decades. We got some really fancy situations like, I don't know, have you ever heard of the time zone -14 or is it +14? Because if you divide the Earth in 24 parts from a latitudinal perspective, still some people are going to decide that they're +14, not -10. And then you get 26-hour days hidden in a calendar. Maybe the 7-week standard that the Greeks invented 3,500 years ago is not going to last. Maybe, I don't know, who knows what the future holds for a calendaring application. It is essentially a political thing, isn't it? And on top of that, we get the best part, the crème de la crème, which is the proprietary services that read the 352 pages of RFCs and say, okay, we're not doing that. It is things like Google. This is a very recent discovery, even. Apparently, there are 2 alternative ways to describe events that were added to the RFC, amended to the RFCs so that applications can embed like URLs or HTML in them and show in a nice UI. And then Google goes there and says, okay, so I'm going to put the HTML in the non-alternative way that is supposed to be plain text. So now we have to parse everything all the time, regardless of what the spec says. Yeah, I think everyone just decided to collectively not follow everything to the letter because it's, on the one hand, you have insane RFCs, and the other hand, you have insane applications. So the in-between is just as crazy. Calendar has some really complicated widgetry. I gave you all a hint about this with the infinite timeline. It is not the only complex thing. I feel like we're pushing GTK to certain limits when doing this, and pushing the platform as a whole, like how much data can dbus transfer in a microsecond until it starts stuttering the UI with 3,000 events. This is a real case that I had bug report for. It's still an open problem. The fact that we have elements on top of elements that sometimes cross the boundaries of elements, widgetry that looks like children but don't act like children, puts us in a very awkward situation. It's still manageable, the application exists, but it's still pretty difficult. I used to say like GNOME Calendar was the first fully responsive application in GNOME, even before libhandy was ever conceived. It's the only application that changes how children behave based on the window sizes. And that was true in 2013, and it's still true to this day. So I think we can hold ourselves this title. And currently the biggest problem is accessibility. And it's a big problem, not because we don't have the infrastructure to make it accessible, but because we don't even know what an accessible calendaring application would look like. What is the accessibility tree of an application, of a calendaring application? Does anybody know? Can anybody even conceive that? So neither do we. We just don't know what an accessible calendaring application is. And that makes it impossible to make it accessible. We have a theoretical problem behind the practical non-implemented problem. Hadi has been experimenting with this. We've been nagging accessibility people to get their feedback on this, but it's very sparse so far. And I think the best feedback we've got is just don't make it accessible, just make the sidebar accessible and ignore all the rest, which isn't great because, like, I don't know, if you want to make the month view keyboard navigation, if you want to implement keyboard navigation, for example, in the month view, suddenly you're having focus on things that are supposedly not accessible. How is the screen reader going to deal with that? That's super complicated. Yeah. So, in theory, we're supposed to have a project management talk from Jean-François, but I don't know if Jean is here. I think Jean is
reporting for duty.
Are you? Oh, there we go.
Then like this disembodied voice from the north.
Go ahead.
Can you hear me fine? Is there any echo? Is the sound too loud or anything like that?
I think it's fine. Everybody's raising their thumbs to you.
All right. Okay. Okay. Project management. What has ever done for us? Anyway, I'll try to be quick. I've been recently crowd curl maintainer, and according to haters on social media, the lead GNOME developer. But I don't actually maintain the code in Calendar. I just maintain George's morale. So let me share with you why I care about GNOME Calendar personally, and then what I've been doing to try to make it exciting for everybody else as well in the past year or two. So let's go to the next slide. Basically, as a business owner, I have a very complicated calendar, which is most of the time filled to the brim. I have a ton of meetings, deadlines, obligations, and I absolutely need solid calendaring software as a complement to my to-do list software application for GNOME. So, and according to what I've seen in recent years, GNOME Calendar is probably the only calendar software that has a chance to truly meet my long-term needs. And that's no small thing. So, and you can trust me on that because I've tested, evaluated, monitored the evolution of pretty much every calendaring application project on the Linux desktop for the past 19 years. So when George told me in 2014 that he wanted to work on this newly born GNOME Calendar project, I was like, oh, wow, that's cool. That's great, honey. Let's, okay, go ahead, and I'll catch up with you in a couple of years and see where you're at in this big pile of requirements from my bug filing frenzy. So and so I saw him again 5 years later at GUADEC, and he told me, "Oh my God, time zones! What is this? I don't even." And throughout this whole time, I kind of kept trying the whole app every now and then reporting issues. But I kept depending on Google Calendar because GNOME Calendar wasn't really up to par yet. And so fast forward to 2022, GNOME Calendar 43 ported to GTK4. supporting light and dark mode, which is something that Google Calendar still doesn't do, and having received lots of bug fixes, I tried the app again and I thought, wow, this has really improved, and I can actually use this. So I looked at the bug tracker, and now we can go to the next slide. And I saw it had 600 open tickets, and I thought, well, this is a lie. There is no way there are that many bugs in this application. And I'm going to take over this bug tracker. Let's see if I can help George get this back under control so that he can focus on fixing bugs and I can bring in some new contributors. Because I think that 600 tickets is unmanageable for a project of this size. I mean, come on. It's, quote, just, quote, a calendar UI app. It's not LibreOffice or a web browser engine. So there is a finite scope of features, like purely talking UX here. So the number of tickets should be lower in reality. So, and you know, when you look at this from the outside, you're like, yeah, any new contributor, potential contributor to a project like this would see that amount of tickets and they would run away because nobody sees 600 tickets and thinks, this is great. I'm going to dive right into it. And that leads me to this fantastic next slide in early 2023, where I asked my co-director, can I spend an unreasonable amount of time, non-billable time, to help the GNOME Calendar project turn around? And she said, go ahead. So I fired up the technical lawnmower, and I spent a couple of weeks and months, more like months, working on a project. And I managed to close about 500 issues during that year. And it doesn't look exactly like that in this slides chart because it seems like I just kind of mowed the lawn and then I sat in the garden with a pina colada with the tickets count saying stable. But then let's go to the next slide and you will see then that just keeping the numbers stable is a continuous effort because the new tickets keep getting filed, even though a majority of the tickets are actually filed by me. Because as we fix fundamental bugs and implement new features, then it opens the way for new follow-up things to take their place. So it's kind of like a tower defense game, except that we're destroying the targets faster than they get created now. So in the last 18 months, 325 issues were created, and I closed 592 tickets. And so by deduplicating it, triaging and doing QA and testing and kind of pre-testing every merge request before George gets to review the code. This cleared a lot of our view and allowed us to have a better overview of what needs to be done, where the actual problems are, where we stand towards my amazing vision of the desired user experience where I can actually sit in a garden with a pina colada. So, and we merged a lot of new and old code merge requests. So that's always a great thing. So it allowed us to do something that fans of the agile methodology are going to cringe for, a roadmap. But that's a topic for another time. So one day, this chart's two lines are going to cross or get really close to crossing. And the first chart from the previous slide is going to go down further. And I promise this will happen. But we need your help to get towards that goal because we always need more contributors, which leads me to the next slide. So, of course, a lot of work remains to be done, and we are in a much better place now than we were even just a year ago. And the app is more featureful, it's more reliable. You can actually trust the time of your events most of the time. And now there are new contributors, so it's very, very exciting. And you can see here some statistics that I calculated at 2 a.m. last night. And there are two key points that I want to draw your attention to here. First, as we fixed some very fundamental architectural issues in the past year, we have also improved the time zones test suite quite a bit. We have solved a ton of bugs. So we don't actually have as much actual bugs as before. Only about 40% of our tickets are bugs. Most of the rest of the tickets, the remaining tickets, are feature requests and enhancement requests to existing features. And the second point is about 40% of our open tickets are newcomers-friendly tickets. Okay, sure, you need to be somewhat comfortable with doing development in C I know this is not super cool these days. Everybody wants to do Python. But this is a great learning opportunity. And if you're looking to do for a new challenge, it's relatively easy for a newcomer to make a great impact on the world by contributing to GNOME Calendar. So send your merge requests. Feel free to join our Matrix chat room. It's both a technical and an informal banter social place. It's a lot of fun. You will be part of one of a hell of a high-impact, outstandingly well-managed project. That's my nickel guarantee. And now, over to you to talk to some of the things on my roadmap. I'm handing the mic over to, well, Harry or George. Thank you.
Let's run through the rest of the slide deck. We have a roadmap. It is pretty big. It is incredibly big. Of course, the first thing we want to get out of the way is accessibility. The only thing that we don't really know how to get out of the way is accessibility. Yeah, if anybody knows, let us know. We're looking for funds for this. We want to see if we can put a paid developer to get this thing done. So yeah, Hadi is going to talk briefly about it. We want to have time zone support because right now we just tolerate people in different time zones and events in different time zones, but we don't expose any way to change them. So it's kind of big in calendaring. We want to get through invitation, but that has a little dirty secret that it also pulls in mailing stuff to other people because that's how that's how calendaring happens in 2024. You mail files to each other, and they accept something in the web UI. It mails you back a calendaring file. We want to get to the point where we are RFC compliant. It's super difficult. There have been talks about doing a calendaring and general portal for this kind of stuff. It's probably never going to happen because we cannot ever agree on what is an event and how they should be represented and all the kind of stuff. But we can dream, right? And something that is on the pipeline is maybe a new backend based on Tiny Sparkle, previously Tracker, because it's going to be much, much, much faster than Evolution Data Server, orders of magnitude faster and better and more sane, I think. Yeah. For funding, let's give a minute for Hadi to talk about it.
Yeah, so one of the things that we
Hadi, can you hear us?
Is, wait, what? Hello?
Maybe not.
Hello.
Okay, I'll just pick it up from here. We don't have much time to wait for it. So, yeah, we've been looking for funding to get especially the accessibility parts of calendar out, but also time zones. We have, yeah, there is a bunch of options that we can use. STF is probably the biggest one, but it's probably hard to get a final end user application funded by the project. So yeah, we're in this situation. If anybody knows anywhere we could look into for funding, please get in touch. This is something we're actively looking for right now. And I think with that, we wrap up. We have 30 seconds for questions. If anybody has questions, please speed run them. I don't think anybody has questions. Yeah. All right. If nobody has anything else, then I think we wrap up just 7 minutes, exactly 7 minutes off the mark. 1, run. Dun 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 dun.
All right, I'm going to ask a really naive question, and there's probably really good reason why this is completely impractical, but a lot of the problems you talked about, as far as time zones and things like that, it seems to me like you and Thunderbird and KDE are all solving the same problems when it comes to things like that. Is there any way for open source projects to all collaborate on at least some of these things that are, there's no reason you should have to rework the wheel when it comes to just handling locale or parsing events and invites. It seems like that's something that could be shared. Is that completely wrong, or?
There's a reasonable amount of shared code that goes through a bunch of libraries like TimeZoneDB and gdatetime. The glib library is a layer that we depend on. But there is still a massive amount of manual work that is probably specific to calendaring applications on the platform they're built into. So I think it's going to be like, I think we're already sharing quite a few things. And I don't personally see much more to be shared. It's just like everybody having to face the same kind of problems over and over. But yeah, I hope that answers your question. Yeah.
Okay, thank you. We're going to start the next session immediately because we started it.
So good to see you all. My name is Michael Catanzaro. I work on GNOME release team, GNOME security team, WebKit security team. Suffice to say, I've seen a few things, and I am more or less convinced that we cannot write secure applications. At least not if we keep writing them in unsafe languages, not as the supply chain gets out of control, and not if we don't sandbox them properly. So it's not all bad news, but we could be doing better than we are right now. Now, I've made one critical error in preparing this presentation, which is I requested the short time slot instead of the long time slot. So I can't get into as much detail as I prefer, but we've got time to hit all the most important points. I just might have to go through some of these examples a little bit quickly. So first off, memory safety will be the first half of the presentation. Here's Memory Safety 101. If you're somehow not familiar with this concept, if you're now a software developer, in unsafe programming languages like C, C++, Vala, common errors which we make all the time when writing GNOME software allow attackers to take control of our users' computers, which is bad. Now, the good news is that doesn't actually happen much in practice because we don't have many users, and attackers prefer to focus on platforms with more users like Windows and Mac OS. But GNOME has been growing, and if we continue growing, this will eventually become a bigger problem for us. Now, attacking is a little bit hard. Now, normally the attackers win over the defenders, but it's not done easily. I'm a defender. I don't know much about writing exploit code for exploiting GNOME applications. As a defender, what we do is we simply assume that every time we see a memory safety error, that is a security vulnerability. If you want to go crazy, you can assign a CVE to everyone, but then you spend all day assigning CVEs to every bug you fix, so nobody does that. But they are all security vulnerabilities, and if you're a security researcher, when you find one, that's what you do. So write errors, these turn into code execution exploits, potentially. Read errors, they can facilitate exploitation of write errors, they can leak sensitive data. It's bad either way. Did I skip over a slide? Yes. So here are unrealistic example memory safety errors. First, the unrealistic buffer overflow. We've got an array of 42 elements. We write to the 43rd element because the arrays are 0 indexed. So that's the buffer overflow. You're writing to memory you're not supposed to be writing to. Here's a use after free. The rest of this presentation will mostly be about use after free. We allocate memory, we immediately freeze the memory for some unrealistic reason, and then we use it after it's been freed. Now, the good news is not all applications are as high risk as others, right? Like, it probably doesn't matter if the calculator application is written in an unsafe language. I guess it downloads currency conversion data from the International Monetary Fund, but I'm not expecting them to hack our users. Like the text editor, attackers don't try to exploit text editors, so not super high risk. But some applications are very high risk, like web browsers, video players, any sort of media player, PDF viewers, anything that displays untrusted images. Images are high risk. Our errors can have serious consequences for users. The most obvious example, we have a criminal GNOME user currently serving a very, very long prison sentence because he opened a booby-trapped video file that was designed to exploit a memory safety error in Totem, presumably in GStreamer. Of course, that's bad because if legitimate law enforcement agencies can do that to our users, so can cyber criminals, so can law enforcement agencies in countries where the law looks a little bit different and maybe just disagreeing with the government is illegal. So we want to make this as hard as possible. So now I'm going to go through some common mistakes I see often in GNOME code. If you're not a computer programmer, don't worry about the details here. If you are, now is the time to pay attention because I have to hit these a little bit quickly. Mistake number 1, failure to disconnect a GObject signal handler. We got a object A, it connects to a GObject signal of object B, and the programmer forgets to disconnect the signal handler when object A is destroyed. So when we get into some signal call back up there, A is already invalid when we try to do something with it. So if you're lucky, maybe this triggers a GObject critical or something less serious, but this can often result in use after free vulnerabilities. I see it more often than I would like. This also has a really easy solution because in this case the user data parameter is a GObject. We can just use gSignalConnect object instead of gSignalConnect. It's only a few extra characters, and now when object A is destroyed, the signal handler will get disconnected automatically and there's no longer a security vulnerability. If the user data parameter is not a GObject, then you have to manually clear the signal handler in your dispose function. It's not hard to do, you just have to not forget. Now, common mistake number 2, misuse of gsource handler ID. I normally see this with either timeout callbacks or idle callbacks. In this case, we register a timeout to execute 42 seconds later. We pass A as a user data, and we forget to keep A alive for the callback. So by the time when the callback is executed, we try using A. It's too late. That's a use after free. Very easy solutions. Solution number 1, ref the user data, unref it in the callback. The downside here is that keeps your object alive for 42 seconds, which you might not want to do. But that almost always works, that solves the security problem. Generally, better solution in your dispose function, clear the timeout ID using gsource remove, and gclear handle ID is the best way to do that. It helps you avoid messing up by mistake. So just don't forget to clear your gsource handle IDs, especially idles, timeouts, if you're using gsource manually. Common mistake number 3, failure to cancel asynchronous function call. I see this a lot. You call an asynchronous function of a different object. You do not pass a gcancelable parameter, and you just you have a use after free if the asynchronous function call completes after the user data has been destroyed. So in this case, the A gets destroyed first, then the function call on B completes, and then this code doesn't show it, but you assume that the asynchronous completion callback is going to use object A. So solution looks exactly the same as the previous one. First possible solution, just ref the user data, unref it in the callback. Then you don't have the use after free problem. But it keeps the object alive. The best solution is to use gcancelable if you can. If you're implementing a G object, just add a gcancelable to your object's private data struct. That's really no reason not to. The fact that the cancelable parameter is optional does not mean you don't need to think about it. Just make sure that when the async function call completes, you don't have a potential use after free. So in this case, we canceled the cancelable in the object's dispose function. And then here, we have to change how we write the async completion function. We have to check for errors because that's how cancellation is indicated. I like to check explicitly to see if the error is canceled, because if it has been canceled, then you don't really want to print a warning message because that's an expected condition. And lastly, notice that we're very careful not to use object A until after we've checked for an error and returned from the function, because it's expected that this callback will be called when object A is invalid. After checking for the error, you know it's not been canceled and you know the object is still valid and safe to use. Mistake number 4, I don't have time to discuss in this short time, but there's a lot of ways you can mess up when using G main context. So I highly recommend studying Philip Wisnall's G main context tutorial. It's not the glib documentation of G main context. It's a separate tutorial on developer.gnome.org. It's a complicated, it's dense reading, but it's pretty important. If you don't follow the best practices carefully, application callbacks will wind up executing at unexpected times with unexpected results. My final example I have for you, failure to disconnect a weak pointer. In this case, we got a GObject A, and it wants to know when the GObject B is destroyed. So it registers a weak pointer to clear the memory location self arrow B when object B is destroyed. And the error here occurs if object A gets destroyed first and fails to disconnect that weak pointer. Then when object B gets destroyed later on, that memory is no longer valid. It's going to get zeroed out. It could have been reused by something else. So you can cause weird bugs in your application this way. It's no good. It's very hard to debug if you cannot reproduce the issue. So be careful with weak pointers. Again, in the dispose function, if you haven't seen the pattern yet, clear the weak pointer, unregister your signal handler, unregister your gsource timeouts, cancel your cancelables. This is all happening in dispose, and it's how you avoid writing these bugs. Unfortunately, none of these common mistakes can be caught by static analysis tools, to the best of my knowledge, so we just have to be careful. But hopefully now that you've seen them, you'll be less likely to mess up. So, some very quick guidance on how to avoid memory safety errors in your C code. The most important rule, sandboxing, Flatpak apps. The Flatpak sandbox is great. I'll talk more about this later. Toolchain hardening. Distributions use hardened compiler flags to make it a lot harder to exploit memory safety errors. You don't really have to think about it. As long as the compiler flags are used, then it makes it a lot harder. Unfortunately, compilers are insecure by default for some reason. Toolchain developers are very conservative, I assume, for some reason. But But yeah, if your application is packaged normally by Linux distros, or if you're using Flatpak Builder to build Flatpak applications, then you're picking up hardening flags from the runtime automatically. You don't have to think about it. But if you're doing something custom, or if you're just building your own software locally, Meson is going to give you insecure binaries by default. So that's something to think about. Static analysis tools, these are really important when working with C software, ScanBuild, Coverity. Dynamic analysis tools are great, Address Sanitizer, other sanitizers, Valgrind. If you have code coverage. If you don't have code coverage, then you don't know how much you're actually testing, right? So the more comprehensive your test suite, the more comprehensive your code coverage, the more value you're going to get from dynamic analysis. Fuzzers are great if you have code that parses. If you have a parser, fuzzers are great for parsers. glib has several fuzz test cases in the OSS fuzz repository, for example. It's a great way to find unexpected bugs. Now, perhaps one of my more controversial recommendations: enable assertions in production if you're willing to do so. Except slow assertions. Don't enable slow assertions, right? Don't add loops to your program to assert stuff. But in general, assertions are pretty quick. You can enable them fearlessly in production if your code isn't broken, and get better bug reports from users when they do get hit. It's also okay. Some developers prefer to leave assertions disabled in production and enable them only in debug builds. That's fine too. But not my recommendation. Critical errors. Do you have the critical errors? These are kind of like soft assertions that don't crash your program. I've recently started experimenting with turning these into fatal criticals using glog set always fatal. I'm very, very happy with this change. I've enabled it in Epiphany in both the UI process and the web process. It has turned up some problems. But it really helps with bug reports, and criticals are often the first step in what's going to become a use after free. So it's a hardening measure as well to stop the program execution before bad stuff happens. Lastly, consider Rust or other safe languages. This is a real complex decision when you want to rewrite code in Rust and when you want to not. Rewriting code is a risk, but it's probably beneficial for our highest risk code. For example, parsers. Parsers are dangerous. Anything displaying images. There's glycine loaders, for example, is much safer than GDK pixbuff. Multimedia. The most dangerous software is where the value proposition is highest. But there is a trade-off. That brings me to my one slide on supply chain security. Now, I'm not a Rust developer, so I'm not familiar with the ecosystem, but I have noticed that our Rust applications bundle a lot of cargo dependencies, and if any one of these has like an exe style backdoor in it, then no amount of memory safety is going to help us, right? The backdoors are game over. So Rust developers, my request for you, talk to other Rust developers about this problem. The situation isn't quite as bad as it looks like from this slide because a lot of these crates are actually produced by the same vendors. So if the same group of people releases 10 crates, then that's really only 1 point of risk, right? But there's different ways that we can mitigate this risk. I just want to make sure we start talking about it and trying to figure out how to improve this. I'm also quite nervous because if there's a security vulnerability in one of these static dependencies, we're going to have to do separate security updates for every application that bundles them. And security updates for downstream Linux distributions are quite expensive, quite difficult. I'd much rather have one security update than a dozen. Now, the remaining portion of my talk, sandboxing. I am a huge fan of the Flatpak sandbox. The Flatpak sandbox is incredible technology. So basically, a sandbox is a constrained environment such that if your application gets compromised by malicious input, that application can only do bad stuff to the user inside the sandbox rather than on the host operating system. So, for example, let's say your application is compromised and it wants to, let's say it's ransomware and it wants to encrypt all the files in your home directory. It can only encrypt the files that you've actually opened in the sandboxed application instead of everything in your home directory. So sandboxing is great. It is a defense and depth layer. It's never your primary security mechanism. So it's not an excuse for like not updating dependencies in your Flatpak manifest. It's not an excuse for security bugs, but it does make it a lot harder to exploit security bugs because now you need 2 security vulnerabilities rather than 1 to exploit the user. It's expected that exploiting applications is generally a lot easier than escaping the sandbox. Sandbox escapes are supposed to be hard. Unfortunately, if you've spent much time on flathub.org, you'll know that it's quite typical to see warnings that your application that you want to install is potentially unsafe. Here we have LibreOffice. It's got full file system read-write permission. All right, so the rest of the sandbox is just worthless at that point, right? It's not doing anything for you at all. This is typical. Now, disclaimer before my next slide. Some of the language on this next slide is a little too harsh on Flatpak. I've been persuaded to remove some of it, except I didn't bring the source code for the presentation with me to Denver. So bear with me. There will be bear with me here. So flatkill.org, if you remember this from 6 years ago, complained to the Flatpak sandbox is a lie. And I agree with that because we're allowing applications to just completely disable it, and users don't pay much attention to the little security warnings we give them. Here's the bullet points that I wish I had not added to this slide. User trust in the Flatpak ecosystem, it's harsh to say that that trust is misplaced because Flatpaks are no worse than distro packages. An unsandboxed Flatpak has equivalent security properties to a package from your Linux distribution. So it's not that I don't want you installing unsandboxed Flatpaks. It's just that I would rather Flatpaks be sandboxed when possible. So the reason applications have so many sandbox holes is because we don't have enough portals for them to implement the desired user experience, right? So the situation with XDG desktop portals is much better than it used to be because George's from the audience. Well, I'm not sure if he's here in the audience right now, but he's taking up maintenance of the portals. He's doing a great job. Thank him. Buy him a drink or something. But we need more. And we need application developers to help us with this when there's a portal that they need and don't have. We need some sort of plan to make these unsafe permissions scarier in the future, including, I'm going to propose eventually, after enough time, it doesn't have to happen overnight, but eventually we should start delisting applications that use unsafe permissions without justification. But some applications just cannot ever be sandboxed, right? Like disk usage analyzer, we probably want users to be able to install disk usage analyzer, or Pika backup, or GNOME builder. There's probably no way we can ever sandbox Nautilus, your file system viewer. So we do need some sort of exceptions. They just need to be much rarer than they are today. So that's my call to you if you're involved in the Flatpak community, or if you package Flatpak applications. The sandbox is really, really good. Let's stop subverting it. All right, this is my final slide. My last recommendations. Distro maintainers, Flatpak is great. Let's think about actually using it to distribute applications in your distribution. We're thinking about this in Fedora. We haven't figured it out yet. I don't think we're going to figure it out soon, but we know that we want to do it. If you're not looking into this, then I hope you're looking into some other mechanism for sandboxing your distro packages. I don't think anybody is, but it's a tremendous security benefit. Flatpak manifest maintainers, keep your Flatpak dependencies updated, everything in your Flatpak builder manifest. Nowadays we have Flatpak external data checker, and if you use it, then you hopefully won't show up on the next version of flatkill.org for having not updated dependencies that have security vulnerabilities. Rust developers, talk to other Rust developers. Let's figure out how to at least keep track of our dependencies better. C and C++ developers, you have my slide on best practices, static and dynamic analysis tools, assertions and productions if you're willing to do so. All right, that's all I have for you. I have a few minutes for questions, maybe 3 minutes. 3 minutes for questions if anyone has questions. I'm astounded if no one has questions. Wow, okay. Well, you can always come up and ask me about any of this after the talk. I'm sure I've forgotten something important because that was a little bit quick, but There you have it. Thank you, GUADEC. We do have questions.
How do you trust so many crates?
Slower, please. I'm sorry.
It's okay. I find it interesting that a particular Rust application can have like 30 crates.
A Rust application can have 30 crates.
30, yeah.
So
How do you trust so many crates?
how do you trust so many crates? So that's a lot less than anything we have in GNOME right now. How do you trust them? I don't know. That's a good question for the Rust developers. They really don't think this is as bad as I think it is, and they understand the ecosystem a lot better than I do. So I can only hope that it's not as bad as it looks. I mean, it's not like it's particularly likely that any of the crates we're using now are malicious. But if we keep using more and more Rust, if as time passes, that eventually one of these crates is going to be backdoored. It's going to happen sooner or later.
I did want to quickly add that I think Rust crates are generally an order of magnitude simpler than equivalent C libraries. Like, you know, there's Rust crates which have 100 lines of code compared to C libraries which have 10,000.
All right. I think you're telling me that the Rust crates are very small. Yes.
Some.
Yes, they're much smaller than C library dependencies, and I've heard them compared to like files in C projects. But they are still separate points that could be compromised.
Okay. Thank you. Yeah.
Thank you very much. Thank you very much. And it is about the Snap packaging system and also the all Snap distro Ubuntu Core desktop. So at first, what the hell are snaps and why should we use them? And it is the case that if you have a free software project, it is usually provided as its source code. And this is only something which tech-savvy users can install. And so you are under the usually you are either under the goodwill of the distribution maintainers, that they package this application for your distribution, or you are so lucky that the free software project takes up the work of packaging their software for more than 10 distros and testing it also. And this is really a nice nightmare. And so we look also at smartphones. There it all seems to be much easier. You have many applications in the App Store or Google Play Store, and you can simply pick one and install it. And when somewhere an application is announced, it just works on your smartphone's operating system, independent of the manufacturer, so which all have slightly different systems. And so, Canonical, they have also already made a smartphone operating system. They have given up, but the Ubuntu Touch system, they have given up on it, but they have learned from it. And this was the origin of a packaging format, Snap, which makes everything working like on a smartphone. Snap exists already for 10 years. Since the 14.10 Ubuntu distro, it's available. And this is the so-called sandboxed packaging, one of the available sandboxed packaging methods. And you're up once in a security sandbox, and so it is encapsulated against other apps, against the host system, and it can communicate only through well-defined interfaces. And when the interfaces are able to do, when it is possible to do something nasty, dangerous through the interfaces, these interfaces are not automatically connected. And the Snap Store, which distributes the snaps, they have to give permission on these interfaces. They have control over them. And so with this, you can trust third-party apps. And this way, you can have applications, install applications which are packaged independent of your operating system. And so you are not dependent on your distro maintainers anymore. And with this, we have operating system distribution independent packaging. And so the free software project only needs to package once and test once, and then the resulting package once on many distros. And this works mainly because all the dependencies or the libraries which the package needs come with a package and do not need to be provided by the operating system. And with this, we have the smartphone-like user experience. So, and Snap has also one special advantage against other sandbox packaging systems. It's that snaps cannot only be made from desktop applications, but they can also be made from system daemons, system applications, even from the kernel and from a base operating system to make up an all-snap distro. And I will talk later about that. Then the packaging with distribution-independent packaging like Snap, the packaging moves from the distributions to the applications, because the application projects can make distribution-independent packages, and so the distributions do not need to package all the applications anymore, and the applications get even updated independently of the distro, so you can have a much newer browser than the release of your distro. And with this Snap, we can form immutable distros, and Snaps itself are some kind of immutable applications. So now we go deeper into Snap packages, and the properties are that the file system content of the Snap packages is a read-only squash-fs file system, GPG signed, and so this is immutable, and it includes also metadata, which is needed for the installation, also to know which interfaces it needs and so on. And when we install a Snap, for each Snap also an encapsulated writable file system is created, so that the Snaps can store status, user data, and so on. And the updates are atomic updates. The Snap is always updated as a whole, as the file system is immutable. The whole file system is replaced by a new one. And to make the updates, to accelerate the updates, the Snap Store provides binary diffs, so that only deltas are downloaded and not always the whole Snap. And this works on many distros, and it exists already for 10 years. And for the security, as I said, we have a read-only system image file system. With this way, nothing can be manipulated. And it is GPG signed, so it can be trusted. And we have a confinement which encapsulates the Snap. It's app armor for the file system, seccomp for the system call restrictions, and namespaces. And the executables are started with special wrapper scripts, and this way the executables can run in this encapsulation without the standard system file system. And this is root safe because the Snap is encapsulated. When the Snap's executable is running as root, it cannot damage anything in the host system or in another Snap. And therefore, especially daemon Snaps, the daemons are run as root. And they do not need and we do not need to make security by having special system groups or system users to manage permissions. And they are also storage efficient because the immutable file system is compressed, and when it's mounted, it does not get uncompressed. The data is uncompressed on the fly when it's accessed. And then we have also, if we have, for example, GNOME application snaps, they would bring all the same GNOME libraries, and these are many, and so we have some snaps to share parts, so-called content provider snaps, which, for example, the GNOME content provider Snap contains all the GNOME libraries, icons, and so on. And the core Snap, the operating system core, is also a Snap. And this contains all the libraries, all the standard libraries, which are used by most of the packages. So, and for snaps to communicate, either with the host system or with other snaps, we have so-called interfaces which do a well-defined communication for a well-defined use case. For example, we have a cup snap, a debus snap, a cups interface, a debus interface, a network interface, debus interfaces, all interfaces for special use cases. And when one creates the snap, one selects which interfaces one wants to use. And so one can well define how the snap communicates. And under the interfaces, there are some interfaces. They are not very dangerous when one connects them. For example, the cups interface. With this, you can send print jobs to cups, you can pull the list of available printers from cups, but you cannot delete cups queues or so. And so this is a harmless, safe interface. And so if you upload the snap to the Snap Store and someone downloads it and it connects to the cups interface, this interface is auto-connected. But there are also dangerous interfaces. For example, the cups control interface, which allows the snap, which is connecting with it, allows the snap to do everything with cups, to create and delete queues, to read the print jobs of every other user, and so on. This is dangerous, and therefore, when you connect to cups control in your snap and a user downloads it, cups control is not auto-connected. The user has to manually connect it. Or you get special permission from the Snap Store team so that that for the user it gets auto-connected. So, and now also important for snaps, the updating mechanism. The updating cannot be done by replacing some files of the snap. So always the immutable file system of the snap is replaced as a whole when the snap is updated. And it does not overwrite the old immutable file system. The old immutable file system is we keep as a backup should the new version of the snap not work. So when we do the update, the original data and the original snap, the writable part also, they are saved. And the new snap, the new immutable file system is put into its place, and the writable data is kept from the old version so that the user does not lose their data on the update. And then when, in the case that the new snap, the user is not content with it, it somehow not works, the user can say, I want to step back, and then the backups are taken back into place, and the user can continue on the old version. And if the snap is, for example, a kernel or boot system snap, and due to some problem, the system is not booting anymore, then the stepping back is even done automatically. So now we have learned about snaps. Now I will tell about an all-snap operating system. And the simplest case of an all-snap operating system is Ubuntu Core. And this Ubuntu Core was the reason why we have Snap, because Canonical has 10 years ago worked on an operating system for IoT. And there they wanted to have the immutable operating system with atomic updates. And so they have created Ubuntu Core. And Ubuntu Core is completely consisting of snaps. And it contains, and the operating system itself contains as first the gadget snap. And this is the snap which describes how the storage media is partitioned and how the system boots. And then there's the kernel snap. This is the kernel of the system. And so you see the kernel is in a snap. And there's a core snap. This is the operating system core. These are all the common libraries which every program is using, the shell, systemd, and things like that. And so this makes up an operating system. And on this operating system, you cannot install Debian packages. You can only install snaps to add applications to it. And it contains naturally also snapd in a snap, so that the snap installations and updates get managed. And this is a simple operating system. It is not. It has no desktop, and therefore it is, as it was designed for IoT, it could also be used for server tasks. And after that, Snap was continued to be developed, to be installed also on classic installations of Ubuntu and on classic installations of other Linux distributions. And then naturally also desktop applications got snapped, and content provider snaps for desktops like GNOME or KDE were introduced, and so on. So that on a classic distribution one could install also desktop applications as Snap. For example, Ubuntu comes with Thunderbird and Firefox and some others as Snap and not as Debian package. So and here we see we have the Ubuntu Core operating system, and we have the applications, and everything is encapsulated and separated from each other. So no uncontrolled access between two of these pieces. So, and now, in the last year, we have introduced desktop support to Ubuntu Core. And so we have extended our Ubuntu Core operating system by one very important component, and this is the desktop session snap. Here, Ubuntu Desktop Session Snap. And this snap contains Wayland as the graphical base, and it contains GNOME. And so we have the GNOME desktop. One can naturally make also desktop session snaps based on other desktop environments, and there are already more than one effort to package KDE this way. And with this, we have extended Ubuntu Core to be a desktop distro. And so the applications we install can be also desktop applications, because we have a GNOME desktop there. And these additional bases, this is as each application, when you snap an application, you have to base your snapping on one of Ubuntu's LTS distros, 22.04, 24.04 or so, and for each one there's a core snap or a base snap, and this snap contains these common libraries. And now it happens that you install applications on your Ubuntu Core or Ubuntu Core desktop system which are snapped with another base system as your operating system, and so the additional base system snap will be installed so that snap has also its correct distros. And the nice thing is, every snap you can replace by another. So, for example, you can add other desktop session snaps to get other desktops available. So that, you, for example, when you start with a Ubuntu Core desktop with GNOME, you can later on add KDE and then switch to KDE. Or you can replace the kernel snap. You can put a gaming kernel in. And so you have the flexibility with this operating system, more flexibility even than with conventional immutable distros, because in conventional immutable distros, everything except the apps is one immutable part, so you cannot replace the desktop or the kernel. Thank you. So as I said, we have principally Ubuntu Core, but we have added a desktop session snap, and one thing is, now you are thinking about how do I do development on it, because we have everything encapsulated in snaps. We cannot have a terminal which can access the whole file system, and I can simply install something from source and to then work on it. And what we do to do development. We take the graphical front-end workshops, and this creates LXD containers of classic systems, classic Ubuntu, but also classic systems of Red Hat, SUSE, and many other distributions. And so in these systems, you can do development. But we cannot release this yet. This will take some time because there are still some to-dos. For example, we need to have NVIDIA driver support for gaming, and the printer setup tools, they work with the CUP snap and with CUPS 3.x. They are still under development to be changed to work in this encapsulated environment. We also need scanner applications to be able to add scanner drivers, which is also under development. We need also more development support. For example, that we have an IDE which is installed as a snap and can access your LXD containers. And TPM full disk encryption, remote management with canonical landscape, Active Directory login, because Ubuntu Core Desktop is also very nice for the corporate desktop where one wants to manage hundreds or thousands of machines. It's much easier with this all-snap immutable distribution. And distribution infrastructure, to be a distribution, to provide a distribution like Ubuntu Classic, you need to create and provide ISOs, you need to do testing, you need stable release tracks, documentation, and so on. And that's all. And now, questions? Yes? Yes. The kernel snap, you have a kernel. The kernel snap, you have a kernel which comes in a snap, but I don't know exactly how it works. Perhaps Ken here?
So yeah, the kernel snap is a bit of a special snap, obviously, because it needs to be able to provide kernel modules and things like that get loaded at boot time. But the OS, which is Ubuntu Core, has interfaces that can deal with the kernel. But the kernel can be updated independently of, like, say, the operating system image. It's a separate snap, and it gets updated the exact same way as other snaps, but it is a special snap.
Any other questions?
Yeah, I wanted to quickly ask about AppArmor, because is this on? Yeah, I think so. AppArmor is not available in all distros, right?
Yes. This is one important problem of Snap. Not all distros use AppArmor. There's one half of the distros using AppArmor, the other half of the distros using SE Linux, and you do only get the full encapsulation working when the distro uses AppArmor. This is still a little bit disadvantage of Snap. The best thing would be if we succeed to convince our Snapd team to add optional SE Linux support. If they would go through all the interfaces and map them through to the appropriate SE Linux rules, because now each interface is creating rules for AppArmor.
But I saw in your slides that it's file system sandboxing. So there's a new thing called landlock in the kernel. Could it maybe use landlock for sandboxing file system access? Then okay. Fair enough. Yeah, okay. Okay, thanks.
Any other questions?
Yeah, I was curious on Ubuntu Core for the IDE support. Are you taking like a VS Code approach where you connect remotely into containers from a snap that's outside of it? Or are you thinking more of like running IDEs within a development container of like Ubuntu Classic?
I'll take this one.
Yes.
I
think I will come closer to you, because when I'm standing here inside, there are no speakers and I don't understand you well.
Till, I'll take this one. So it's not fully designed yet what we're going to do, but basically in Core Desktop, for example, we're bundling LXD in it so you can run containers and things. And the idea is when you install VS Code as a snap, it'll have the ability to talk to that container. So you can have multiple containers, and VS Code will be able to drive the individual containers. There will, in all likelihood, be a seeded container inside the image that allows you to install, say, Debian packages and things like that, that is just for running things that aren't available as strict snaps. So when you go into the snap store and say you want to install VS Code, which is a classic snap that has a lot of permissions, it would actually automatically install it inside of this container and run it from inside that container. GNOME Shell will surface the icon. When you launch it, you're running it inside that container. But it would be able to drive development in any container you have.
One follow-up. Are you working on a replacement for like Microsoft's proprietary container integration?
Not necessarily, probably our own thing.
Okay, cool.
I think we're
Yes. Thank you very much. So,
thank you.
And sorry, Ryan, that we have perhaps a little bit over one.
Sipes is going to be talking about Thunderbird, the death and rebirth of the OSS project. Take it away.
Thank you so much. Now, before I get started, one thing I wanted to ask is if we could all give a round of applause for the organizers and volunteers running this event. This is clearly a labor of love for them, and it really shows. So, my name is Ryan. I began at Thunderbird as the community manager. And let me think about this. What do I want to say here? It's been a journey. It's been a crazy journey. It's been ups and downs, left and right, whatever you can describe for like, I like to think of it as a hero's journey, you know? But it's been a wild ride, and you guys are probably getting the best firsthand accounting of it here today. But before we get into that, I want to tell you what we're doing for you, okay? So Heather right here has worked on GNOME system tray support, which should be landing very soon in Thunderbird. And some other things that we did this year is Flatpak, FlatHub support. We adopted our Flatpak. We're now taking care of that, making sure it's up to date. It's really great to have an option beyond here's a tarball for when we're asking folks to use Thunderbird on Linux. We also did snap support. Well, Heather once again did that. And then we have native Exchange support, which I know Exchange is gross, but it'll be one of, by my count, 2 or 3 Linux email applications that actually natively support Exchange. So I just wanted to call that out. And then the most fun part of this is most of our developers are Linux users, and we're very excited to say that 2024 and 2025, we're going to increase the support for Linux platforms in Thunderbird. So that's really interesting and fun. Okay, who am I? Ryan Sipes, Managing Director for Product at MZLA, which is the Mozilla entity that Thunderbird lives in. International Man of Mystery? Bird lover? I don't know. Maybe you guys will find out today. So I joined the Thunderbird project as its community manager in 2017, part-time on contract. I was never intending to be working on Thunderbird for more than a year or two. I thought the community was interesting. The product was interesting. One thing that I thought about a lot when I was at System 76 is I was community manager over there, and these organizations would call me and be really excited, and they would say, we're deploying Linux across either our entire organization, or they would say a specific group, like all developers are now going to be running System 76 machines with Ubuntu on it. But the question that would come up in each of those conversations was, they all are moving to these Ubuntu laptops. We've been using Outlook. What's the one-to-one replacement on Linux? And I started looking into that and testing all these different applications that ran on Linux. And what I would tell them was Thunderbird because it was the closest. But in reality, it was not a one-to-one replacement. And so when I saw that they were looking for a community manager, I thought I was like super hot stuff. So I was like, I'll go over there and I'll fix this up, you know, and then it'll all be great and balance will be restored to the force. And this 7 years later, I'm still working on it. So there you go. But yeah, that's me at Thunderbird. Now, Thunderbird probably shouldn't still be alive. In fact, when I joined, one of the most common questions that I got. Not just from normal Joes, but from people who are plugged into open source software and everything, and it was, Thunderbird, isn't Thunderbird dead? And it was a good question, actually. This was in 2012. There was an article declaring the death of Thunderbird. And Mozilla declared that it was shifting its focus away from the email application to other things. I have a quote here. In summary, we've been focusing efforts towards important web and mobile projects, such as Boot to Gecko, while Thunderbird remains a purely desktop-only email client. We have come to the conclusion that continued innovation on Thunderbird is not the best use of our resources, and given our ambitious organizational goals. And this is from JB, Managing Director of the Thunderbird team. So, yeah, you could excuse people for thinking that Thunderbird was dead. And here are some reasons Thunderbird might actually have been dead. No one was employed to work on the project. Thunderbird was frequently in an unbuildable state. I remember getting there, and we had what were called red tree days, where upstream broke us, and red tree days were really gracious, because usually that actually meant red tree months, where we couldn't build Thunderbird for a very, very long period of time. There was no clear vision or roadmap for the future. I say that there were still active community members, but there just was not this driving vision that they all shared. They weren't going anywhere in particular. And as many of you have already asked me about today, there was no sustainable funding source. So, but, okay, I'm standing here talking about Thunderbird, so clearly it wasn't truly dead. And there's this quote, "Rumors of my death have been greatly exaggerated. Mark Twain, but more famously Thunderbird." Yes, Thunderbird wasn't dead. It still had an active community. This is the applause line where everybody says, "Woo! Thunderbird! Community!" Yeah, thank you. You guys are going to have to get better at this. I'm not going to tell you every time. So that takes us into the rebirth of Thunderbird. Oh, yes. So this was my mantra when I started Thunderbird. Is there sound to this? Well, you can't hear this because it's on my laptop. Wait, let me try something. Yes.
What is dead may never die. What is dead may never die. But rises again, harder and stronger.
What is dead may never die. I repeated that all the time. After I started Thunderbird, they're like, "This isn't going to work." And I was like, "What is dead may never die." Okay, let me get my mouse back here. Nope, I don't want to see this again. Okay. All right. Well, that's all well and good. We're here now, and we'll talk about what that looks like. But how did we do it? How are we still alive and thriving? It's a little bit of a spoiler, but... Well, first, we set up some governance. Mozilla wasn't going to steward the project anymore, so we created a body that would steward the project. The Thunderbird Council, pictured here. For those of you who don't know, that's a Jedi council. You see Yoda back there. That's how you know. Okay, so the council played a pretty big role in saving Thunderbird. And what can you draw right now from the council that you can apply to an open source project? I'll tell you. It created stewards of the project. Why is that important? In any project that is going to be successful, an individual or group of individuals have to have responsibility for that project. Unassigned responsibility means a project is going to die. There's just no question about that. One other thing that it did is the council was an elected body from the community, so it created an openness that actually re-energized what was really a low morale project. Okay, you get spun out from Mozilla, no more money being spent on the project. That's very bad. That is like circling the drain type of project. However, creating a body of elected contributors to shape the future of the project, well, that's re-energizing. Okay, all right, we can get together, we can figure out some of these problems. So openness, important there. And it ensured that there were decision makers, ownership. A little different than responsibility, because everyone in the project may feel responsibility for it, but at the end of the day, somebody has to say what's going to happen, what's not going to happen, where we're going to focus our efforts. And then the last thing that they did was they hired me. OneNote. Okay. So you're like, Thunderbird Council, great. They're going to change everything. Everything's going to be great. It's going to be flowers and sunshine forever. Good governance, even the best governance, is never pretty. I can say this pretty unequivocally. Maybe it's different in GNOME, but so far let me think about this. Okay. So been in open source communities since I was 12, all right? And that's been a long time. I'm 34 now. I have yet to be in a community that works, that doesn't have any sparks flying every day, real debate happening. And I will say that if you look back on Thunderbird's mailing list at this time, it's not pretty. It's not pretty. Constant arguments, constant, I don't know, competing visions for the future. But what I'm telling you is you have to have that in an open source community for things to actually move forward. If you don't, then the project is probably stagnating. And then I know from everybody's questions, what you all want to know about is my question after I'd been there a little bit and my contribution. So shortly after I joined, some article shared Slack's daily active user number. And I looked at it, and it was around 10 million daily active users. And I looked at ours, and with the exception of the summer, when all the Europeans disappear from using Thunderbird, we also hovered around 10 million daily active users. And I saw some other thing that Slack produced, that their revenue was $1 to $2 billion at the time per year. Ours was on track that year to be $500,000. And I thought, what? How is this possible? Daily active users, we know from what telemetry we do have that Thunderbird's really sticky. People are in it from 4 to 6 hours a day. So it's like very important. What is happening here that we are going to die? That Thunderbird is going to slowly just disappear from the world. And so I started asking, like, why aren't we sustainable? To which there was no good answer, but I kept asking it. And we did some things. And we've become pretty sustainable. This is another applause slide, just so you know. That's that first year that I was there, and that actually came in a little bit better because we tried some things, $700,000. This is last year at $9.1 million in revenue. Just so you understand, that is an 1,100% increase over that time. Okay, yes, we understand. How did you do that? Okay, I'm getting there, okay. It was actually really simple. I kept trying to think of all these super complicated ways to make money for Thunderbird. And all of them were pretty bad ideas. Or we would try them and it'd be like, yeah, okay, you could go sign up for a new email address in Thunderbird. Maybe some of you knew that. Probably most of you don't, because I have the telemetry numbers for how many people did that, and it's very low. And we made like $1,000. And so that didn't work. So we kept trying things. And then finally I was like, well, okay, crazy idea. What if they don't know that Thunderbird is going to die? And what if we just like slap it like right in their face? And that's what we did. So you can see this first appeal. And what I heard as I pitched this idea was asking for money is so uncool, or some version of that. Got a lot of feedback that people just didn't feel comfortable asking the users for money. They said it's spammy, it's tacky, it feels like early shareware. And I was like, and it took a while for me to figure out how to have that conversation, because I was like, yeah, it does. It doesn't feel great to like be like, give us money. But then I thought, as I was talking to users and they would tell me how important Thunderbird is to their daily like work and like their life, I realized we were kind of talking about the wrong thing. So my question back to them, which is more cool? We ask for money twice a year, or Thunderbird goes away forever? Then we started getting somewhere. Then people were like, well, yeah, I guess that's true. And one thing that open source doesn't understand, because so many of us folks are doing this for ideological reasons, is, well, we'll get into a lot of those, but one of them is that anything you do does not have as much impact as you think it does on your users' lives. Case in point, I take over Thunderbird with a big thing that pops up in your face that you have to exit out of, asking for money. Let's go back to that slide. It said, nope, I'll get there. This popped up full screen. There's more to it than this. It says, help keep Thunderbird alive. This is taking up your whole screen. Did you know that less than 1% of Thunderbird users fund all the work we do? Not too long ago, Thunderbird was on the verge of extinction. You can all see this is all bold. It's because of donations from a small group of users that we're here today. We don't show advertisements or sell your data, and we are completely funded by donations from our community. Okay, so really aggressive kind of appeal. And that popped up on every single of our approximately 20 million total user base screen. And I went around afterwards, did a bunch of user surveys. What did you think of the appeal? What appeal? It popped up, it was a whole thing. Like you had to exit out of it to get around it. Bro, I do not know what you're talking about. What is going on? I know it hit our users. What happened? So I figured it out. Okay. So, users are so accustomed to seeing ads and promotions and upsells in applications that one a year it did not trigger at all in their psyche. You either gave or you clicked X, and that was a 2-second transaction in your day. So, this stuff is not as annoying as you think. Still, we are coming off of doing 4 appeals over the last 12 months. Okay, 4 full screen appeals. Still, many of the users I ask, because I have it in my list of questions, say, I honestly have never seen what you're talking about. So far, we have not hit any kind of fatigue around the in-app appeals. Okay. So that's raising money, and we'll talk more about that. The third one, everywhere I went, Thunderbird is dead. Thunderbird is dead. Thunderbird is dead. Thunderbird is dead. I know, Thunderbird is dead. Okay, thank you. Had to change that. Another thing open source projects aren't really good at, a lot of open source projects. Owning their image, their brand, the perception of their project. I know that that's a challenge because a lot of folks who are building open source software are developers first or engineers first. So it's not an innate skill that a lot of folks possess in this space to tell a story about the application that they're building or the project that they're building. This was Thunderbird's story when I came. It was a lot like this picture. Thunderbird was perceived as old, a little confusing, and parts of the interface looked like they were from a different era. My job, as I saw it, was to tell this story. It's a little dangerous, yeah. It's cool. We're a cool, scrappy community taking on the empire, Outlook. And we look damn good doing it, don't we? Yeah. So, to do that, I kept looking at, I should have put it up here, the old logo. I kept looking at that logo, and every time I just saw a wig on top of an envelope. And once you see it, you can't unsee it. And I was like, this is not the future. This is not even today. Like, something's wrong. So, despite everyone telling me, don't do this, I was like, we need a new logo. Like, don't do this. Everybody knows the logo. It's fine. People be confused with something new. But I was like, if we don't change this thing, everyone already knows what Thunderbird is. They know what it is. They see the logo, they know what it is. They know what's inside of it. Even if we change everything, even if we're not even an email application even anymore, we're just a Bitcoin wallet or something, they're gonna see that and they're gonna be like, I know what that application is. I used that in 2004. I know what that looks like. I know what that experience is like. So fundamentally, we had to tell them, no, you don't know what this is. You've never seen this bird. Is that an egg? We don't know. You don't know because we don't know. So we rebranded, we got a new logo. And then the other thing we did, which once again, like nobody understood, but we gave that next release a really fancy, cool name. They're like, what does it mean? I'm like, I don't know. Since then, people have like given it meanings like, oh yeah, it's blowing everything up and there's a supernova and everything will come back together into something beautiful. That's not why it was named that. I was just like, this just sounds cool and people will want to know more. But we did real things besides just rebranding. When I asked folks like, what's people who are coming and using Thunderbird and leaving, I would try to grab as many of them as possible and say, well, why didn't you stick with Thunderbird? It's kind of a weird, like, who are you? Like, where did you come from? Why aren't you using Thunderbird? And they would be like, well, honestly, it looks like it's from 1999. I was like, yeah, you're not wrong. So in this release, we decided we're going to just destroy expectations, like change the user interface as much as we can. Not without purpose. Like we didn't just change it arbitrarily, but we said we know where we're not maybe the best, most modern experience. We can bring that into 2020, I guess this would have been 2023, into 2023, and create an experience that matches expectations for what a user interface is in this year. So we told a new story. And it worked out. Years go by, years go by, years go by. This is Supernova, and that's our user base ticking up. So it worked. And we've continued that. This is our release that just came out 4 days ago. The 10th, the 12th, 7 days ago. Yeah. And we continued that work on the user interface design. Isn't that pretty? Yeah, really cool. Okay. So I'm 30 minutes in. Do I need to stretch this out longer or do I need to make it shorter? Here we go. Lessons learned. What you can take from this and apply to your own project. If you want to be successful as an open source project, it's not just about the code. I'm sorry. That is just it. You know, there's so much more that drives what decisions users make about the applications and the software that they use. It sometimes has absolutely nothing to do with the code quality, the language that it's written in, the cool thing that you manage to do that no one else does on the planet. That's not actually how users make decisions, or a lot of users make decisions about the software that they use. There are other elements to that decision-making process, some of which are intangible. They're not based on the quality of the software. But some things that we can implement as a wider open source community that can change open source for the better. One is that governance matters. Now, no matter what happens to our revenue, no matter what happens to our leadership, no matter what happens to Mozilla, no matter what happens to MZLA, Thunderbird will likely continue to exist and continue to grow and continue to change or continue to die, but they will exist. Why? Because we have a governance structure that is for the project that is independent of anything else. So as long as there are people showing up to develop the software, there will be elections that will be held to determine who leads the project, and that will continue to provide a structure for the project to exist regardless of what happens. So when I think about longevity of open source software, this is one that I think about quite a bit, which is like, okay, you're maintaining this piece of software, like, what happens when you, I shouldn't say get hit by a bus. Lots of other things could happen, lots of good things. We have maintainers all the time who have kids, and then we have to find a new maintainer for the thing that they maintained. So, okay, you have kids, all right. Like, you want to create the structures in your open source project so that the project can continue and do good things, even if you're not present. Okay, and I put under here, it isn't always pretty. Just a reminder, if you're like in a project and you have a governance system and there are arguments and stuff, I need to tell myself this sometimes too. Sometimes you just need to sit back and be like, this is like how human beings collaborate and come to answers and come to decisions, and like, that's okay. It's okay. Sometimes it's not okay. Code of conduct, like, you know, there should be a little bit of rules of the road, but like, if two people just disagree on how a specific feature would work, that's healthy and that's good. And hopefully if you have the right rules of the road, a good decision will come, a better decision will come out of that process than otherwise. Okay. I don't know who needs to hear this. Somebody in this room needs to hear this. Money is not necessarily bad. And let me give you a reason. Because at first this was just a slide that just said money is not bad. And then I thought about it and I was trying to think through like how do I back that up? There are some jobs in an open source project that are either extremely difficult or so draining that it is very hard to get someone to do it for free. No one has ever, in the history of Thunderbird, updated the IMAP code for free. It has never happened. No protocol code has been updated, to my knowledge, by someone who is volunteering. Do you want to know why? You were talking about it earlier. It's like 600 pages of RFCs. Who wants to do that? That is not like, I'm going to get my whiskey, I'm going to sit in my chair, and I'm going to read through the RFCs tonight. Like, no, it's not sexy work. You never get thanked for it. Yeah, it's sad, but it's true. And so, in that way, it's good to have money, especially if you have a user base that you can draw some money from, to tell them what it is that you want to do and to ask them if they want to support that so that you can tackle the big, hairy projects that are really difficult to get a volunteer to do. And the last thing on this point, I feel like as someone who loves open source software, like with a deep burning passion, we all need to learn this a little bit better. When I was pitching this to the Thunderbird Council, the Thunderbird community, I got so much pushback around money, around just trying to get money to move the project forward. And it was kind of eye-opening because the advantages of the software we're competing against is that they don't hold our values, and they're deploying a lot of resources toward promoting, in some cases, the antithesis of our values. And if we're not willing to use a tool in the toolbox in order to compete, then it is our destiny to get left behind forever. So anyway, on that positive note. The last one is own your story. The last thing to learn from this. I began this talk with someone else telling Thunderbird's story. The little bird with the X over its eyes, it looks like that's it for Thunderbird. That was the story. And no one tried to tell another story. That was just the story, and it was allowed to live from 2012 to 2017. Of course, that's not the story. I remember conversations with developers. We're here. We're developing the software. Everybody knows that. Like, because we're here and we're doing it. No. No. Nobody knows that. So we end with Thunderbird telling the world what its story is. We're alive. We're thriving. I'm here today. I'm inceptioning this into your head. Like, we are the open source email client that's taking on Outlook, that's taking on Gmail, that's taking on the proprietary applications that are out there that allow you to access your email in order to show that there's a better way. There's a better piece of software that you can use to accomplish something that you need to do every day, which is manage your email. But, okay, the last piece of that story, so you all can tell all your friends. Our values are our users having a good experience, not a good experience as in UX experience, as in no dark patterns. We're not going to show you ads in your inbox. We're trying to help you, the user, accomplish the thing that you want to do with the least friction and the least moral compromise possible. That is the Thunderbird story. Owning and telling your powerful story consistently is a big part, and perhaps the biggest part, of shaping reality to match your project's dreams and ambitions. The end. That is it. And I think about GNOME, and I think about this trend that has happened ever since the inception of GNOME, where we roll out a feature on the desktop, and we're like, this is so cool. This is so cool. And then 8 years later, Mac or Windows adds it to the operating system, adds it to their desktop experience. Okay, well, what story should GNOME be telling? You know, I don't know, spitballing here, I did not think of this before, but, you know, like, an example of this would be like, GNOME, it's the next generation desktop, always. It's always the next generation. What you see here is what's gonna be there in the future. Like, that's badass. That's a story GNOME should be telling every single day, or some story like that. Letting people know, you're a developer, you think you're cool? You're not cool. Are you on a next generation desktop? No, you're not. I'm not today, I'm sorry. My other laptop broke, and so this is the backup. So I'm part of the problem right now. But as I was sitting today, watching everyone using GNOME, while I was stuck on this, I was like, that looks so much cooler than what I'm doing over here. Thank you. Do we have time for questions? Cool.
All right, here we go.
First of all, thanks for coming. That was awesome. I have two questions. One's kind of geeky. How is the council elected? Like, who can stand and who can vote? And the second one is, are there any, obviously there are positives to having money and hiring people and getting stuff done, which is super cool, and I'm in awe of what you've achieved, but have there been any downsides to the project and the community?
I didn't catch the second question. Can you repeat it?
Has money caused any problems for you? Right? Has having the money in the budget had any negative effects on Thunderbird or the community?
Still maybe a little bit closer. I'm so sorry. Had to get like near the speaker here.
Has money caused you any problems? Any downsides to the community?
Oh, any downsides to money?
Yep.
Oh. I know why I couldn't hear that question now. Sorry. Okay. Council. First question is, who can stand for council? What are some of the things that determine that? The council, you need to only contribute, I think it's only the equivalent to 5 hours of work. It's 5 or 10. We're pretty lax with that rule, but you need to show some contribution in that year. And like the reason we say like 5 to 10 hours of work is, you know, like updating the README doesn't necessarily probably qualify you to stand for the council, but you know, if you send a few patches or help with the design, few design sessions, whatever, that makes you eligible. So it's not super stringent. Has that created problems before? Maybe. But, you know, ultimately, we'd rather have them be less stringent and more potential passionate people get in than have them be less stringent and more passionate people get in than the opposite. Has money caused problems? If you look at it from a perspective of, is Thunderbird consistently better year over year because of money? The answer is, it hasn't caused that many problems, because like Thunderbird is improving and improving more rapidly, and we're closing the gap between us and other applications like Outlook that exist in the space that are really powerful. I think that the downside is that as you add people who are paid to work on a project, you get less unless you really combat it hard, you get less volunteers standing up to do hard things. Because they're like, oh, well, you know, Jim's getting paid. He can do the hard thing. Like, I'll do the little thing over here. I wish that wasn't the case. I think that if there's a future talk, it would be figuring out how we get people to remain engaged at the same level that they would be if we were strictly volunteers. But at this point, we just don't know enough, and we haven't tried enough different things to figure out if that's even possible. So, yeah.
I want to preface the question by saying I am a happy Thunderbird user and this doesn't fit my profile, but I think an elephant in the room here is Mozilla Thunderbird ever going to address webmail? Because there is just an enormous number of people who want to use webmail. They don't want to use a desktop client. Full stop. Is there ever going to be a day where you guys tackle that? Because there are a lot of users that have to settle for proprietary options because there just isn't a good free software webmail.
Yeah, that's a good question. The answer is, I imagine that Thunderbird will exist if the trend that you saw continues, or maybe doesn't like continue the 1,000% increase, but just even maintains. I imagine that a Thunderbird webmail experience will happen. We're already moving into each mobile platform, Android and iOS. That work, Android is, you can download K9 Mail today, which we adopted and have poured quite a lot of resources into. We're starting an iOS project this year. And to me, there's enough shared, if not code, there's enough shared concepts that we know, and we know really, really well, that we can move on to each major platform as we see it. So we have all the desktop platforms, including like FreeBSD and everything. We have Android and iOS in the pipeline, and I think web is the last one that we need to create a presence on in order to say Thunderbird has an email, calendaring, and contact solution for you, regardless of the platform that you're on, which is a goal of mine and a goal of our team, is to be everywhere that the user is. I don't know. I don't have a timeline for that.
Yeah, I got a question. I was impressed with your revenue numbers. They look great. Do you have public information of like a breakdown by platform or anything like that?
Yeah, if you go to stats.thunderbird.net, you can see a breakdown by platform. One problem that I have with Linux users that I'm going to air right now. I'm going to look at the live stream. If you are a Thunderbird Linux package maintainer, stop turning off telemetry. We don't know how many Linux users we have because of you. Stop it. You're not helping your cause. We don't know whether we have 2 million Linux users or 500,000. Please turn telemetry back on. Let the user opt out if they want to. Telemetry, guys, we do not collect any PII. We only collect platform and a few other usability data points, not any PII. We need to know how many Linux users there are so we can make decisions about whether or not to solve problems for Linux users over existing problems on other platforms where we do collect telemetry. I believe that there are probably more Linux users on Thunderbird than macOS users on Thunderbird, but the telemetry currently does not say that. And so we make decisions based off of the platforms that we can see and that we know users are on. So, yes, stats.thunderbird.net, and go check your Thunderbird installation, and if telemetry is turned off, please turn it on.
Are Linux users generous? Do they donate more than other platforms, or is it...
Say again, sorry.
Are Linux users generous at all? Like, do they donate more than other platforms?
Yeah, Linux users are generous. We do have we do see an outsized, for what we can see in telemetry, we do see an outsized representation in donations. So that is very good. Keep donating. You can leave telemetry off if you donate. But yeah, they are. Yeah, I'm trying to think if there's any other relevant stuff there. We receive a lot of feedback from Linux users. And that's going to make you guys laugh, but it is helpful. Like, you know, those folks are the types of folks who are most likely to come and tell us about a bug that exists and tell us in detail, which is useful to your point earlier, George? Yeah, about calendaring. It's really helpful when you have someone who's willing to dig in deep and figure out, like, not just like calendar's not working right, but, you know, I think it's this and that that's causing this issue. So not all bad for Linux. I'm sorry for yelling at you earlier, but turn telemetry on.
Do we have any other questions? All right. Do we have any online questions?
It's okay to give a short answer because this maybe is a question with a long answer.
Go ahead.
We could talk about it later, but how do you own your story? If you realize at a certain point you don't own your story, how do you get from there to a point where you own it?
Yeah.
Like, if there's a bunch of things that people say about your project and, like, I don't know, it's slow or something, and, you know, if you make a blog post saying, oh, well, we're not slow at all, then you sound really defensive. Like, you know, feel free to give a short answer, and then I'll come and talk to you later for a long answer.
Yeah, I'm of two minds on this. One is tried to be accessible, try to be authentic, and try to be, this last one's hard, try to be everywhere, but that one's extraordinarily hard and you will get burnt out being everywhere. But you kind of have to sometimes. When combating Thunderbird is dead, okay. Each message needs a different strategy around it. For Thunderbird was dead, I said, what's the opposite of dead? It's like really, really alive, like too much alive, you know? And so I was like, Thunderbird just needs to be that for a little while, like go everywhere, talk to everyone, you know, go to a podcast. It's like, what are we talking about today? We're talking about cats. It's like, you know what cats love? Cats love Thunderbird. And just like keep bringing that back, because if they see it everywhere, it can't be dead. If Thunderbird's everywhere, it can't be dead. If, you know, your application is slow, okay, the alternative approach to that probably is, okay, either it's actually slow, okay, which you just have to hit everyone constantly with like, we're making it faster. Here are the things we're doing to make it faster. We're making it faster. And you just keep saying that and saying that and saying that until the other people on the internet who are interested in your story internalize that, and then they will be everywhere for you. Linux is really good at this. Linux projects, open source projects are really good at this. You eventually get a critical mass of people who show up everywhere and say, they repeat your talking points. That's the answer. You need to have your talking points and you need to hit it all the time until people on the internet start posting on Reddit threads for you with your talking points. That sounds trivial, but you see it all the time in open source from time immemorial. Like, you have seen it. It used to be Ubuntu, you know, like you didn't need Mark Shuttleworth, even though sometimes he did show up in, you know, places, but you didn't need him to go and explain what they were doing. Folks would just show up there. It's true of a lot of different things. It still exists for a lot of great open source projects today where folks show up and they tell the story, but you have to have the story down first in your head, and it has to be like your mantra that you wake up with every day and be like, and all of your team has to know it. One thing we struggle with as we've grown as a team is not everyone's telling the same story, which doesn't actually accomplish owning your own story because you can't have more than one. You have to have one at a time. I hope that answers the question. Maybe I can go more in, but I got to think about that a little bit, but I will, for you. Okay.
I've got the microphone. That's me. So I'm just going to ask. I was going to ask 2 questions, but you just answered one of them. The second one is that here in the GNOME community, we have quite a few people who have been advocating for metrics and telemetry for a decent amount of time. And you know that the Linux community is particularly difficult to get that through. So maybe I just, can you just repeat, pointing to the camera again, the message about turning on telemetry, please? We really need to get that.
You know how I talked about owning the story? What everyone here who cares about making good open source software has to do is start actively telling the story. There are, I think, much less people who are really opposed to telemetry, or they're not making their argument in good faith, that are making this really difficult. Because when I asked my team, okay, well, we had people join our team, and somebody restarted the conversation, I remember this, of like, telemetry, like we're collecting telemetry, like why are we doing that? Like that telemetry equals bad, like that's bad. And it's like, my question to them was, okay, well, we're not collecting any user data, we're not even collecting IPs. All we know is what platform are you on, what version of Thunderbird do you have, and I guess there was like, how many times do you click this button in a session? But nothing that doesn't contain any email data or anything like that. It's just, is this button being clicked? And so we went through that. We create a heat map. I think it's heatmap.thunderbird.net, or you can find it. Go on GitHub, go to Thunderbird repos, there's a heat map. We had all these folks who were telling us when we were looking at the context menu, don't change the context menu. Everyone I know uses it, I use it. Do not touch it. And for the longest time, we were like, well, maybe we shouldn't touch it. Like every time we talk about changing it, like these same people, these come out of the woodworks and they tell us, don't touch it, don't touch it, don't touch it. Until we hooked up telemetry to those buttons. And granted, they may have one of these people or all of them may have had telemetry turned off, but one of the buttons they were like, don't touch that, had 0 telemetry clicks over the course of a year. 0. So I was like, you're not clicking this button. No one's clicking this button. This button has never been clicked. And we're removing it. When we removed it, no one said anything. Because no one was clicking it. Or they had telemetry shut off. Turn on telemetry. We need to get past this as a community. There's, like the money thing, it's another thing that we fight with our arm behind our back. If we can't know anything about our users who aren't willing to yell at us in the issue tracker, then we will not know enough to compete against the other applications in our space that are proprietary and blah, 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 all the bad things. So, we're just putting this argument behind us as Thunderbird community and saying, we need this data. It's really hard to make any good decisions without it. And you can either, the pitch to make to communities and stakeholders who don't want telemetry is, okay, what happens if we're trying to make a decision and telemetry supports the outcome that you want and we go a different way? The problem is you don't have any data to back up your argument. So you can't say, I use that button is widely used, and actually have anything to back it up, because you may not be the maintainer. You may have a maintainer who's like, I don't care. I don't like that button. It offends me. I don't know why it looks like that, and removes it. And so, you know, it serves everybody to have a common set. This is so 101. Like, it serves everyone to have a common set of data to discuss and make decisions off of. And a community like ours, an open source community, should be embracing that, not you know, shying away from it. Sorry. I get passionate about stuff like that. And do not email me. Do not email me about that. Unless you're telling me you turned telemetry on.
We probably have time for one more question, maybe two. Any last minute questions? Oh, here we go.
This is maybe an out of left field question, but I'm curious. I feel like there's been a rise in like privacy preserving email, like Proton and such, in similar companies where their product is like very privacy focused, and so it's more locked down, and you have to either use a bridge or like set something up locally to get like something like Thunderbird to work. So I'm wondering if you guys are looking at all at like making it easier to integrate with some of these like new, more privacy preserving email services.
Yeah, that's a really good question, and it's difficult. Like, first off, privacy respecting email and some of the stuff that's happening in that space is like so cool and so great, and I'm so happy that it's happening. To like Proton Mail and projects like it, like Tutanota, I really wish they were engaging with the specs, enhancing IMAP, enhancing or developing a new standard instead of doing non-standard ways of doing this. Even if it's open source, even if the bridge is open source, the problem is that Proton Mail is doing something that is unique to Proton Mail and is not enshrined in a standard. So it makes it really hard to implement the bridge, even if we can look at the source code and copy it, because we don't have the rules of the road. We don't understand how they're making their decisions or what, you know. And so I would ask these folks who are doing this really great work to come and participate in the creation of open standards around the things that they're doing, so we can interoperate but understand a little bit more about, you know, with them the rules of the road and how we're going to do this and how we're going to continue to be interoperable. One thing Georges and I were talking about earlier around calendar is email and calendaring is really under threat as a standard, because Gmail, who is the #1 email provider, Outlook, who is the #1 business, Microsoft, who's the #1 business email provider, and calendar, you know, goes along with that, are not following the standards. So it means like we implement the standard, but then we're like, okay, we wrote that code now, and that's going to work for all the small players. Now we're going to have to rewrite all of that code to support the stuff that Gmail and Outlook are doing, which is really frustrating, because like the beauty of email and the beauty of the way that calendaring on the internet has evolved is that it's open and it's an open standard, and you can interop with people on other, it's like what we want with chat. It's why we're interested in Matrix, right? Like, you want this shared language that allows you to, in a federated way, talk with other people on the internet. And that breakdown and the burden that puts on clients, third parties, et cetera, to integrate is really high. So my only thing is, I love the privacy-focused email. I love the innovation that's happening in that space. I hope that folks like Tutanota and Proton Mail and others will come and participate in the development of standards around these things. Not just around OpenPGP, where they're interested in, but like, if you're gonna if you're going to create a custom protocol by which people connect to their accounts, like turn that into an open standard, and we'll help. We'll help. If you want help, we'll help, so that we can all kind of move forward together on this and create a better email and better calendaring and better all that stuff together. So there you go.
Thank you. Thank you so much.
Thank you. Thanks for the time, guys.
And in person, we do appreciate it. We want to thank our sponsors as well for helping us put on events like this. I'm Melissa Wu, and to crib the infamous Ryan Sykes, at the risk of being uncool, we need your help too, right? Because asking for money twice a year, you know, is well, I'll let him finish that. But thank you to everybody that's made a financial contribution to GNOME and the foundation. For those of you who haven't yet but would like to, those of you online who can go online, there's a URL. It says donate.com, donate now. I don't know, actually. We can figure that out. And then for those of you here, we do have this QR code on this sheet. Looks like this. Be sure to stop by the registration desk, click on it, and send some money our way. We also make some money in t-shirt sales, so don't forget to pick up your amazing GUADEC 2024 t-shirt with the Denver logo. You can get this, not logo, with the Denver skyline. You can get this here in person or online on our shop. And for those of you that are here, we have a couple of other announcements. Let's see. Oh, actually, before you guys go online, we are starting here at the same time tomorrow, which is 10 a.m. Mountain Standard Time. We do have a few tickets still left for our social events, which is baseball on Monday and the city tour on Wednesday. And if you want to sign up for a lightning talk, we still have some spaces available there as well. Last but not least, we're going to do our group photo on Sunday after the sessions are over, so please make sure you stick around afterwards. So thank you everybody for joining us on our first day of GUADEC 2024, and we look forward to seeing you tomorrow in person or online.